the countries in the EMMENA region. We started our activities in 2007 at the Department of Civil Engineering and Geomatics at the Cyprus University of Technology. Through the EXCELSIOR funded project, we received a funding of 38 million euros, and we upgrade our lab from ERATOSTHENES Research Center to ERATOSTHENES Center of Excellence. Here are the details of the EXCELSIOR funded project. We received this big funding from the European Commission under the Spreading Excellence and Widening Participation pillar. From the Horizon 2020 Widespread TIMI2 is a coordination and support action. We received 38 million euros, 15 million euros from the European Commission, 15 million euros from the Cyprus Republic, and 8 million from the Cyprus University of Technology. The duration of the European project is 7 years and another 4 years from the government of Cyprus. What is the mission of this EXCELSIOR project? Is to upgrade the existing remote sensing and environment lab into a sustainable, viable, and autonomous center, the center that we have already established, the ERATOSTHENES Centre of Excellence. What is our vision? Our vision is to become a world-class digital innovation hub for Earth observation and geospatial information, so as to be the reference center in the Eastern Mediterranean, Middle East, and North Africa region. Can you see my slides?
Yes.
Okay. Eleni, can you see my slides?
Yes, we can see.
Okay.
We can see it in presenters view, so maybe you can change the settings.
Okay. Let's continue about the structure of our center. We have 3 departments that concentrate on the research activities. We are using Earth observation and geospatial information, especially in geoinformatics, for 3 departments. We have the Department of Environment and Climate, we have the Department of Disaster Risk Reduction, and we have the Department for the Big Data Analytics. On each thematic area, we have different applications. As you can see on the diagram, on the environment and climate, we concentrate on Earth observation for atmosphere, agriculture, water, and land. On the resilient society, you have the disaster risk reduction, cultural heritage, access to energy, marine safety, and security. And on the big data analytics, we are concentrated on Earth observation and geoinformatics, and especially we give emphasis on information extraction, visual exploration, visualization, crowdsourcing, data fusion, and geoinformatics. About the 5 areas that we want to be excellence in research is Earth observation for access to energy, disaster risk reduction, water resources management, and climate change monitoring and big data analytics. As you can see on the diagram on the right-hand side, except from research areas, we have also infrastructure area, education, and entrepreneurship. I would like to highlight that in the next few months, we try to establish the Cyprus Space BIG, the Business Incubation Center in our Center of Excellence. Up to now, we are around 60 people that have already employed in the Center of Excellence, and our plans until end of 2026 to employ 112 personnel, both administration and technical and research staff. Up to the next 8 years, we are planning to employ up to 132. In the next 2 years, we are planning to move to the new state-of-the-art offices and laboratory, around 2,000 square meters in the municipality of Polemidia in Veregaria. As you can see on the diagram, the 2 main highlights of our infrastructure is the ground satellite station, the DASH, that we have already went for tenders, and we are ready to assess our tenders. And in the next 1.5 years, we are planning to have the ground receiving station in our premises in Cyprus. On the right-hand side, you can see that we have already established, we are at the stage of receiving more equipment, the GPS. ground-based atmospheric station that consists dystiometer, microwave radiometer, poly-X Raman LiDAR, cloud radar, Doppler LiDAR, solar radiation station, sun lunar photometer. Through the establishment of the Center of Excellence, when we wrote the EXCELSIOR proposal, we received commitment and letter of support of more than 100 organizations, universities, and SMEs. As a Center of Excellence, we have a lot of MOUs that we have already established through mutual collaborations with European and international partners, and the EXCELSIOR consortium that we are running in order to be able to support the ERATOSTHENES Centre of Excellence consists the following partners: the Cyprus University of Technology, the ERATOSTHENES Centre of Excellence, and the Department of Electronic Communications from Cyprus, NOAA, the Beyond Center of Excellence in Greece, two German partners, DLR, Tropos, and two affiliated partners, CYRIC and the PMOD WRC from Switzerland. Very quickly, some activities on each thematic area. About atmosphere, we are using Earth observation to support air quality, air pollution, aerosol cloud precipitation, interaction, atmospheric dynamics and wind, monitoring extreme atmospheric events, dust storm and dust intrusion, climate change monitoring. We are a member of the ACTRIS national infrastructure with the Cyprus Institute, the EMMENA. We have aerosol and cloud remote sensing activities, observational platforms. And I would like to mention especially some past and recent project that we are running as a university, as a ERATOSTHENES Centre of Excellence. We are running now the ACCEPT funded project from Norwegian funds and several other projects and activities under the atmosphere thematic cluster. Here are some previous campaigns that we did with our partner Tropos from Germany. And about the agriculture, we are very active in different thematic areas: precision agriculture, smart irrigation, water resources management, carbon footprint, hydrological modeling, common agriculture policy applications, soil health, pest disease control, food security, food safety, early warning system, damage assessment and mitigation strategies for extreme weather events. I would like to highlight that we received an Excellence Cup Horizon Europe project with the IPEC in Thessaloniki. The name of this project is Carbonica and deals with the carbon footprint of agricultural crops in different countries, including Cyprus. Up to now, we have already established our agricultural living labs. We concentrate on the involvement of key stakeholders from Cyprus and European level. And what we are doing, we want to combine different technologies, state of the art, in order to motivate our key stakeholders, especially in Cyprus, so as to start using Earth observation and other state of the art technologies like IoT and UAV. About water activities, we are dealing with water quality monitoring, water leakage, hydrological modeling, groundwater modeling, feasibility mapping, land activities. We did projects in the past, but we are using Earth observation to support land cover, land use changes, urban sprawl monitoring, real estate, urban heat island, spatial planning. We did a project in the past for monitoring land cover, land use for different municipalities in Cyprus, urban and regional planning, dam generation for photogrammetry applications. Here are some past projects using land cover, land use, and Earth observation. And about the disaster risk reduction, we are very active in different areas. I would like to mention that we received a funding from European Commission recently, 6 months ago, for using AI for supporting our center activities in the area of disaster risk reduction. About disaster risk reduction activities in our center, we concentrate on the forest fire, bird area mapping, soil erosion, soil degradation, geohazards, plant monitoring, epidemics health, early warning, decision support. And what we are doing, we are very active in using sentinel data to support, for example, earthquake impact assessment and mapping, landslides, forest fire in Cyprus and to the EMMENA region. And We have a good collaboration with different key stakeholders in Cyprus. This is some snapshots that we support using Sentinel data, the Department of Forest in Cyprus, to map the burn areas on a previous fire events in Cyprus 4 years ago and 3 years ago. We are very active on using earth observation that we integrated with hydraulic modeling to support flood risk assessment at catchment scales in Cyprus and the EMMENA region. Very active in cultural heritage. We run different projects under Horizon 2020. We are running 2 funded projects under European Commission Horizon Europe. The 2 funded projects are Trigueta and Enigma. What we are doing now, we are concentrating on the UAV photogrammetry application, study of unexcavated areas, archaeological assessment and modeling, cultural heritage digitization, protection of cultural heritage, risk assessment from natural and anthropogenic hazards. Here are some examples that you use in the past: earth observation to support earth observation of cultural heritage risk assessment in Cyprus and the EMMENA region. We have a project on dealing with monitoring excavation and non-destructive mapping of cultural heritage sites. We have good experience. We're working also within the center and within the university, Cyprus University of Technology. We're supporting the Department of Antiquities on digitization, 3D modeling, protection of European cultural heritage from geohazards, study using earth observation to detect crops on archaeological areas. And as I mentioned before, we are very active on cultural heritage using earth observation, and now we are using earth observation on 2 funded projects, Trigueta and Enigma. We are very active also on marine safety and security, on bathymetry, land and water line, wave groups, wave breaking, surface currents. We did a project in Cyprus using earth observation and WebGIS to support the marine spatial plans development in Cyprus with the Deputy Ministry of Shipping, using earth observation to detect Posidonia, oil spill, ship detection, wind, and sea state. Here are some snapshots on the marine spatial planning development of Cyprus that we support the government of Cyprus through Interreg-funded projects. And we are very active also on using earth observation on energy. We have already established within the Energy Department a solar radiation energy lab under the ERATOSTHENES Centre-of Excellence. What we are doing now, we are ready to announce a UV index determination using earth observation. And what we are doing, we are going to announce this application for the Cyprus region, and we are going to expand this application to the EMMENA region. We are very active also on determining the effect of aerosols and clouds on the levels of surface solar radiation and solar energy in Cyprus. And very quickly, I'm going to announce and mention some list of applications and services that we are ready to provide. Some applications are more mature, and we are ready to provide to our partners in the European level, on international level, but we want to concentrate in the Eastern Mediterranean, Middle East, and North Africa region. I'm going to mention some technology applications that we have already prepared, and we are ready to provide these services for the public and private sector in the Cyprus and the EMMENA region. Very quickly, we divide these application services on mature and under development. I would like to mention some of them. We have already developed internally through our center the Acri Nexus Hub tool for agricultural applications. We are on TRL 5. What we are doing, we have an open platform that we use in Sentinel data. This platform is under demo or application on the Cyprus region for determining evapotranspiration and irrigation demand in agricultural crops in Cyprus. But we are ready to extend this platform to the EMMENA region. UV risk assessment tool for health and agricultural applications. This is a collaboration between our center, PMOD, WRC, and NOAA. Cyprus Geohazard Observatory for Earthquakes and Landslides. This is a collaboration through our center and NOAA. Earthquake Risk Assessment Tool, we are on TRL4. This is a collaboration between the Cyprus University of Technology, ERATOSTHENES Centre-of Excellence, and University of Sheffield. And another application that is ready on a TRL4 is allocation of electric vehicle charging using GIS. This is a collaboration between the FOSS Centre of Excellence FAEFO in University of Cyprus and our center. What we are doing, there is a European guideline to find suitable areas in the Cyprus region, but we can extend this to the EMMENA region for allocate electric vehicle charging infrastructure in the area of Cyprus. We have some other proposed applications that we are still using, and we have this under development. I'm going to mention some of them, showing harvesting tool for agricultural applications between ERATOSTHENES Centre-of Excellence and NOAA. Carbon farming platform. This is a product that we are planning to propose through a Horizon funded project that we have with IPEC. It's called Carbonica. What is aimed to determine immediately the carbon footprint of any agricultural plot and agricultural crop in Cyprus. Cyprus Fire and Flood Observatory, a collaboration between ERATOSTHENES Centre-of Excellence and NOAA, and through the GPS atmospheric station that we have already explained before, and I explained you the parts of this GPS. This is a collaboration between our center and Tropos, and we are ready to announce some thematic application through this infrastructure. Marine identification system, early warning system between our center and DLR, marine pollution monitor, DLR collaboration, digital tools for risk assessment for cultural heritage, our center and DLR, digital technology tool for identifying unknown bearing archaeological sites, our center and DLR, and I'm going to explain two mature applications that will be useful to be used by the EMMENA partners. The first one, as I mentioned before, we are on the beta version. Up to now, we have key stakeholders from the Cyprus region that they are using this application. From national agencies, we have the Ministry of Agriculture, the Water Development Department, we have Farmers Association in Cyprus, agricultural industry like the Cyprus Missouri plantations in Limassol. We have separate farmers that are using this application, and we have providers that we are planning to approach to come across with this application. What we are doing is an integrated web application to support stakeholders to determining the evapotranspiration with the main aim to have immediately the irrigation demand for agricultural crops in Cyprus. The strategic partners of this application, a web application, we have the company software development that did this application for us, Spectrum. We are planning to extend this application through our strategic partner, Cyprus Telecommunication Authority, and we have the key stakeholder that is coming from the governmental sector, the Agricultural Research Institute, who monitors the irrigation demand and agricultural crops demands every year for the Ministry of Agriculture. These are the stages and phases of this AgriNexus Hub. As you can see, we are on stage and phase 1. This is a web application, and we are on stage 2 on now, and we are planning to move to phase 3. As you can see, we are going to incorporate different state-of-the-art technologies so as to have irrigation water management from web application. The pilot study of the AgriNexus Hub is the Cyprus Missouri plantation in Limassol. Is around 6 hectares of land, and we are planning to apply this to the Agricultural Research Foundation, Agricultural Research Institute in Pittsburgh. Up to now, we have been approached from several stakeholders, not only from Cyprus, but from EMMENA region, especially from Israel, Tunisia, and Egypt. And this is another mature application that we have already developed, and we propose this to EMMENA partners. And this is the day today to discuss any collaboration on the end of this workshop. And what we are doing, this is a service for monitoring and forecasting solar radiometric quantities related to health and agriculture. And this is an ideal application to support not only the health thematic areas, but also the agricultural users. This is my presentation today. I would like to thank Eleni and the rest of the team for monitoring this workshop. And I'm looking forward to meet you at the end of this workshop for concluding remarks. I will give the floor to Dr. Marinos Iliadis to continue with the next presentation. Thank you very much.
Thank you, Professor Hadjimitsis. So yes, we continue with a presentation by Dr. Marinos Iliadis, researcher at ERATOSTHENES Centre of Excellence, and his presentation will be on mapping of Earth observation in the EMMENA region.
Hello from me. Just a second to connect the presentation. Don't know if you can see it, Eleni.
Yes, but it's again on presenter's view.
Just a second. Now?
Yes, perfect.
Okay. So, hello, my name is Dr. Marinos Iliadis. So, the title of the presentation is Mapping of Earth Observation in the EMMENA region. So, it was a review that we did on current Earth observation applications in the EMMENA regions with all the authors that you can see here. So just an overview of what are we going to present. First, a short introduction and the motivation of this work. We'll show a few things about the methodology, the results until now, and some conclusions. So, EMMENA region is a fairly new segment for Earth observation activities, and this will show it also in a slide that will compare EMMENA with the rest of the world in its ending slide. The countries of the EMMENA region share areas of uniform needs, context, and common environmental concerns. And from the above, we can see that there are opportunities to establish collaborations, partnering schemes, and mutually exploiting the developed innovations. But to do this, first we need to map the research done in the EMMENA countries, identify the research needs, and seek for potential collaborations. And the aim of this paper is to provide a review, as I said, for the current Earth observation applications and the knowledge gaps. So moving to the methodology, we went through the Web of Science, and we searched from the topic for remote sensing satellite Earth observation or GIS information. We further constrained the research for the EMMENA countries that you can see here in the slide. And we did this research for the past 5 years, from 2018 to 2022. We also categorized the papers that we found in the following thematic areas: atmosphere, water, agriculture, land, disaster risk reduction, cultural heritage, energy, marine safety and security, and big Earth data. We should mention that big Earth data, and most of the times, this thematic area is supported to the other because it includes artificial intelligence, machine learning, geoinformation, etc. And further to this, we selected the top 10 highly cited papers from each thematic areas, and we further analyzed those. So moving to the results. So we found a total of 6,647 publications that they had a geographical focus in the EMMENA region that you can see in the map here. Iran was the country with the most publications, 1,883 in total. And Bahrain, it was the country with the lowest number of publications. And you can see from the numbers that we have 2 orders of magnitude difference. And this was from the MENA countries, we had many differences in the number of publications and also for the author affiliations or co-author affiliations. We should mention also that from this publication that we found, 44.8% of the authors' affiliations are not within the MENA regions. If we compare countries according to their populations, the highest author affiliation per capita is for Cyprus, so it's around 770 affiliations per 1 million people, and the lowest author affiliation per capita is for Libya and Yemen. We should mention that these countries also suffer from political and war conflicts. So moving here, we identified the authors with the highest number of publications in the MENA regions. We should mention that 12 of these authors have affiliations in countries not included in the MENA region. 10 authors have affiliations in Iran, and the remaining 3 authors have affiliations in Morocco, Cyprus, and Saudi Arabia. We also identified the satellite data used in these studies. So we searched through the title, keywords, and abstract to find the satellites used. Here we show the results in percentages, except the total, that was the total number of the keywords that we found. So we can see that the majority of publications for Earth observation application in the MENA regions are mostly for Landsat satellite data, which cover more than 50% of the applications. And from these, Sentinel-2 and Sentinel-1 for the Sentinel missions have the majority of the publications. And for the Landsat missions, Landsat 8 has the majority of these applications. Also, here we show the results per thematic area, the percentage of the papers that we found that belongs in each thematic areas. Here we can see that big Earth data have the highest contribution with around 27%. This is also due to the fact that, as we said before, this thematic area is many times supportive to the other areas. Surprisingly, we found that for marine safety and security has the lowest contribution. This was really strange because the MENA region is covered, many countries are covered by sea, so it had a contribution only 0.9%. And also surprisingly, we found low contribution for the cultural heritage. And MENA countries are very rich in cultural heritage. So moving for what we identified from the 10 highly cited papers from each thematic areas. So begin with the atmosphere, we found that 4 out of the 10 highest articles in these thematic areas focused on the impact of coronavirus on air quality through Earth observations. Other studies in this area, the remaining studies, focus on precipitation estimates, improvement of carbon dioxide from anthropogenic emission measurements, on climate change, and on dust storms. What most of the studies highlighted is that there is a need for higher spatial resolution and better imaging capabilities. So moving to the next thematic area of water, all the 10 studies that we've found, they were focusing either on mapping groundwater potential or mapping groundwater quality. All the studies did this with the use of GIS software and geostatistical methods, but in the studies used different models and different algorithms. What the studies highlight that now there's no current agreement or reference on which approach, meaning about the models and the algorithms, is more suitable. So moving to the agriculture, we found that there is a wide range of topics such as evapotranspiration estimation, land suitability for agriculture, irrigation mapping, agricultural land loss, and crop monitoring. All the studies highlighted that they contributed in improving agricultural management practices, but they said that future studies should focus on different crops and soil types. And another thing that also the studies highlight is that there is an increased need for in situ data in order to verify the Earth observation results. Moving to land, most of the studies combine values of data in order to create erosion susceptibility maps. What the study said that the selection of data approach and techniques depends on the data availability and the site-specific characteristics of each studies. Land also included some other studies like land use land cover monitoring, forest biomass estimation, and soil properties mapping. So for the disaster risk is the thematic area with the highest average number of citations from the top 10 papers that we show. You can see it in the right figure. So there is a huge difference from the rest thematic areas. Most of the studies focus on landslides and on floods with the use of machine learning and artificial neural networks. What all the studies highlighted is that there is a need for development of early warning systems or forecasting systems for landslide and floods. So moving to cultural heritage. Cultural heritage, the publications that we found, they are dealing with the detection, monitoring, and management of archaeological sites, and also about looting detection. What the studies highlighted, again, like the previous, in what that there's lack of common practices, and there is a need for harmonization of methodologies. And another thing that they highlighted in this thematic area is that there is also a need for very high resolution images, which most of them are commercial, and also for LiDAR data. So for the energy thematic area, all the studies are focusing on the spatial assessment of the energy potential and on the location selection for energy plants. When we say energy plants, the studies focus mostly on solar energy plants, 2 studies on offshore wind energy plants, and 1 study on bioethanol plant. What we found from one paper on the global energy, it was a review on the global energy. It says that the EMMENA region, especially the Arabian Peninsula and the Saharan region, presents superb solar potential. So this provides opportunities for developing solar energy at national or international level. What all the studies do is the use of GIS and analytical hierarchical process methods in order to have the results. But again, in this, the criteria for the selection differs from study to study. For marine safety, as we show in the previous figure, has the lowest average number of citations. And most of the studies here focus on the oil detection assessment, toxicity assessment of heavy metals, environmental pollution, and detection of litter, etc. What the studies identify is that there is a need for a near real-time warning and alert system for pollution cases as a service which can help to find a responsible ship, platform, and whatever is responsible for this pollution. The big Earth data, as we said, is usually supportive to the other thematic areas. It includes technology and development methods and algorithms. We found that there are, in all papers for the disaster risk reduction, we found high contribution there of the big Earth data. But what we also identified is that there is lack of fundamental research in this thematic area. For the other, it was the papers that we found, and they were not we put the categories in any of the previous thematic areas. So these papers include animal species detection, identification, and monitoring, socio-demographic characteristic, optimal siting of electric vehicle charging stations, evaluation of bike share stations, and examining the walking accessibility, willingness, and travel conditions of residents. So moving to the conclusion, this is the figure that I said before. compared to the rest of the world, EMMENA region has the contribution to Earth observation studies is very limited. It's only 3% of the studies done worldwide. As we showed in the beginning, Earth observation studies are highly uneven between countries with the EMMENA region. And this is where we need centers of excellence like ERATOSTHENES, that they are acting as digital innovation hubs for Earth observation in the EMMENA region. They can help in expanding Earth observation research and seeking future collaborations and knowledge transfer schemes among the EMMENA countries. Another thing that we are identified is that research in some thematic areas like the marine safety or the cultural heritage is limited. What was identified in most thematic areas is that there is a lack of harmonized methodologies in specific scientific domains. There is also a need for services related to early warning and decision support system. And a few other things that we identified is lack of freely accessible, very high resolution images, lack of in-situ observations, and lack of fundamental research in the domain of big Earth data. So thank you very much.
Thank you, Marino, for your presentation. We will continue with the presentation by Professor Hesham El Askari on the changing climate of the Mediterranean and the increase in sea surface temperature.
Thanks, Eleni. Can you see my presentation?
Yes.
Okay. So as you heard, the title of my presentation will be on the changing climate of the Mediterranean and the increase in the sea surface temperature. And I think the topic fits very well after what we heard from our colleagues, like, outlining the importance of Earth observations and all the different kind of activities which are being carried out at the center. So this is here, a clear representation of some of the usage of these data sets addressing one of the major issues that we are all facing over the Mediterranean basin. I'm not going to go deep in this slide because all of you are aware of the different kind of the possible warmer worlds that we are facing in the near future by the end of this century, be it an extreme situation, a moderate or at ease one, but even with the observed, if we have a global basin stewardship where everything is being addressed to the utmost, where different kind of organizations are taking their role in order to address global climate change situation. So still, we are talking about the 1.5 degrees Celsius scenario, which is in my opinion, far-fetched, as well as the other scenarios, which are the 2C by the end of the century, or even higher than that, where major water-related impacts are going to be observed in terms of food security and other issues, which will affect crop cycles, droughts, crop failure systems, biodiversity issues, and so on and so forth. So we are aware of the different components which are comprising our planet, that we call them the spheres: the atmosphere, the hydro, the litho, the cryo, the bio. All of these spheres are in harmony with one another, and we are addressing, using Earth observations, as mentioned by my colleagues, different kind of the system core, like the core of the Earth system science, dealing with atmospheric composition, Earth surface and interior, water and energy cycle, weather and atmospheric dynamics, carbon cycle, ecosystems, climate variability. And this is what we said when the Earth system science reveals the previously unseen planetary truth. So these are all facts, and we have been observing all the changes. However, maybe some of the layman people will not be aware, or are not able to understand the extent of the issues that we are talking about. However, Earth observations are capable of showing us or revealing for us some of the existing planetary truth that maybe people are not even aware of. But as mentioned before, also, like, with the advancement in the air system science, like there are a lot of different kind of pillars which contribute to these different kind of advancements, be it in the technology areas where, like, we are aware of the constant and the ongoing changes in technologies and, like, the upgrades which are happening as we speak, the different kind of platforms and the flight systems which are being developed to address different kind of scientific questions, like, be it water related, food related, different kind of marine environments, biodiversity issues, and so on and so forth. And that requires a lot of research dealing with the data sets which are being delivered from these flight systems, and analysis. And this is exactly along the line of the different kind of activities that we are observing at the center, and the different kind of scientific issues that they are addressing, which requires a lot of deep in data and compute analysis, because dealing with massive amount of data sets would require massive infrastructures, and this is what we are observing, and this is what, when we call the curse of dimensionality, we are facing massive amount of data sets which are being developed, and we are trying all the time to employ or to look into the interplay between data sciences and Earth observations in order to deliver some of the meaningful applications or to address some specific needs at different localities at a global level. This is in Arabic language, and this is what you are observing right now. Was a feed on the news in Egypt about a lecture that I delivered like years back, when I spoke about the Mediterranean, and I spoke about Alexandria being one of the cities which might be facing some major issues as a consequence of global climate change and the warming of the Mediterranean's water. And that presentation was highlighted in some of the outlets, media outlets, but it did not attract attention to the level that happened when Prime Minister Boris Johnson spoke in the Glasgow COP meeting years back, before the COP27 that was held in Egypt last year, when he spoke about Alexandria as being one of the cities which might be facing some issues in case of a scenario which is approaching 3 degrees Celsius. Showing you the different kind of Earth observations utilizing different regions of the spectrum, be it in the visible, in the infrared, or the microwave, and the different level of content or the different level of information that we are able to collect, be it like the reflectance from the top of the cloud cover, or the heat content like through the infrared channels that we are observing, or the water content when we are looking into the microwave region of the spectrum. So looking into these different kind of animations here, we are aware of the beneficial utilization of different regions of the electromagnetic spectrum, and the level of information that can be revealed about the content of different kind of cyclonic behaviors or events that we are observing along the Atlantic Ocean. This is the development of some of the hurricanes which hit the east coast of the United States. However, it is common to observe these different kind of tropical cyclones that can develop over the Atlantic Ocean, but it is not common to observe things like this over the Mediterranean basin. And the extent of those events are increasing. Their aggressiveness is on the rise, and this is a satellite image from the EOS platforms, MODIS, NASA MODIS on platform Terra. You can see here the cyclonic behavior and the cloud cover, which appears on the left-hand side, and also the satellite infrared image from Weather US on the right-hand side. And this is animation of the development of this event, which happened on the Eastern Mediterranean years back, and the forecast for it, showing you the heavy downpour of water on the Mediterranean east coast, as well as on the neighborhood countries in that region. You can see the extent of the event. that made us start to look into what might be the driving forces for something like this to be happening, to observe tropical-like events which are occurring in a region which is falling totally outside the tropics, because the Mediterranean is above the tropical region. However, we are observing a behavior which is not very common in a non-tropical region. However, since the 1980, the Mediterranean sea surface temperature has increased between 1 to 2 degrees Celsius over the past 3 decades, which is quite an increase that we are observing, and it is expected in the IPCC report, the AR6 that came out months back, that the Mediterranean basin might be facing an increase in the temperature by around 5 or more degrees Celsius by the end of the century. And this is this kind of change in the Mediterranean sea surface temperature is definitely quite supportive of the unusual mid-decade type storms. This is showing you the global trends coming from the National Centers for the Environmental Information about the temperature. You can see the sea surface temperature, global trends, and it's showing you the constant increase on the rise here. And when we are deseasonalizing the data and looking into the deseasonalized, taking the climatology outside of your data, you can see also the trend of the data, which is over the past 3 decades since 1982 until more recent, and you can see the uprise and the constant increase in the temperature, in the sea surface temperature trend component, and which is quite alarming. And looking into that, we did some analysis using sea surface temperature total variability and creating different kind of intelligent geo-intelligent platforms which can observe and monitor. You can see the water is getting toastier here on the Eastern Mediterranean and the Mediterranean in general. There is definitely a global sea surface temperature increase. And looking into different kind of annual variability, you can see the average multi-layer sea surface temperature over different years, and you can see the 12-month behavior over the past 12 years, and you can see the change from in the more recent years, like 2020, 2021. You can see those curves, how they are quite increasing from the norm from before over the past decades. And you can see from this plot the variability over the past maybe 50 or plus years from those gray scale plots which are falling below the dark line, and those in comparison with those falling above the dark line. And when we want to observe the change in the anomalous behavior and see the exacerbation that we are observing in the sea surface temperature, this is quite alarming figure that I'm showing right now, which is showing you the average Mediterranean sea surface temperature anomaly, and you can see in the 80s, the 1983 and beyond that, it was on the negative side of the anomalous behavior, where you can see a cooling anomaly on the Mediterranean waters, and the intermingle between cooling and average to zero, where you don't see much variability until I would say until the decade that starts from 2000, and then the first 10 years of this 2000, you can see the inclusion or the appearance of some warmer anomalies until 2013, those first 10 12 years, the beginning of this century. And you can see here starting 2013, you can see the massive rapid acceleration in the positive and the warmer anomalies that we are observing until recent. And of course there is no promise that is going to be going lighter than that. So it's we are observing, or we are expecting to see some different kind of changes in the anomalous behavior, which might even be higher. That mandate platforms that I call geospatially intelligent solutions, because when we are talking about the global climate change issues, vulnerable locations, we are also talking about mitigation and adaptation strategies. And for me, like, when we talk about Africa, in general, or the Middle East region, like, we are mainly highlighting adaptation strategies, because in Africa, as you all know, like, the carbon footprint from Africa is not massive to be a great or a big contributor to the mitigation efforts required from other nations at a global level. So adaptation strategies which are more viable and more feasible for the African continent and for North Africa requires or mandates knowledge, and requires having intelligent systems like this in order to observe, so that you can have the adaptation strategies built on what you are observing and built on these different kind of decision support systems. Another geospatial intelligence solution, which is showing you the global temperature anomaly mapper at a global level starting from the 1800s. And you can see the monthly or the annual variability in different localities when we are changing the different spots on different locations of the Mediterranean. The curve down there is changing to show you the different variability from one spot to another. As you can see now, when we are moving the cursor from one location to another, you can see the plots are changing, and you can see the mean temperature anomaly by year is also changing. The most important part that you can see here is that in the plot showing you the anomaly, you can see the red bar diagrams towards the end, like in the last 20 years, and you can see the extent of this positive anomaly, which is kind of persistent over that region and over that time domain, regardless of where we are changing the locality over the Mediterranean basin. You can always see in the past 20 plus years that positive anomaly is persistent, and it is quite constant there, which is telling us, like, it's quite important to be aware of what's happening in the Mediterranean and how this can affect also the different kind of currents, because with the warmer waters we are observing, you can expect to have changes in the water currents and the motion of those heat fronts from one location to another, creating areas which might be suffering major tropical like events, and can be associated with heavy downpour in some parts of northern Africa, which is a cause of concern for a place like specifically like Alexandria. Here I'm showing you different solutions which are geospatially intelligent, having the HiCoB model, for instance, and looking into the extent of the water currents variability when it is associated with warmer waters, just like showing you prototypes of different kind of solutions, which I think are kind of important. And this is high resolution model from the NASA model, and showing you the injection of the warm anomaly or the warmer waters into the system. And when this is happening, you can see how the water currents are changing at different global levels over the Atlantic as well as over the Mediterranean basin. And you can see now the warmer currents are being injected, and when you are putting more heat into the system, and that can how this can affect the cyclonic behaviors that we are observing in the Mediterranean basin. So these are issues which in my opinion needs to be looked at and need to be assessed, so that we can have early warning systems, as discussed by Professor Hadjimetis, about those early warning systems, which is quite important. We did some preliminary analysis here in Alexandria by creating 1 kilometer resolution models in order to see the impact of those precipitation events over the coastal areas of Egypt and specifically over Alexandria. So we downscaled our domain from the global to the regional all the way to 1 kilometer over Alexandria only, in order to be able to see at a better level of accuracy the impact of what we are observing in these areas. The second part of my presentation here dealt with different kind of global phenomena in Nino La Nina, and we wanted to see the impact of a global phenomenon like this, and how much it plays a role in the changing pattern that we are observing on North Africa. And probably all of you are aware that El Niño is a disruption in the teleconnection between land, ocean, and atmosphere, where a warm body of water keeps mingling in the Pacific Ocean left and right, which is associated with the wet and the dry occasions, or wet and dry events and phenomena, which happens at a global level. The phenomena is global, the impact is quite local because it varies from one location to another, and the impact on Africa might be different from the impact on Europe, and might be different from the impact on the Americas. And you can see here the El Niño impact at a global level, where some areas are suffering wet events as compared to others which might be quite dry. And this is showing you a historical record of all the El Niño and La Niña events, which I'm pretty sure that all of you are aware of. We are all observing some kind of dry spills, some kind of droughts, but at the same time forest fires in Europe, but at the same time some flooding events as well. And there is a belief that there are some kind of interconnectivity between those global different kind of events and El Niño and some of the local impacts. This is the El Niño monitor global multi-year impact, showing you some of the changes on Africa and different parts of the world. And you can see here the impact in terms of water scarcity, which is an issue for Africa specifically. And you can see the impact of drought on Sudan and Ethiopia is quite dramatic in the coming few years. So we started looking into the sea surface temperature anomalies from 1980 until 2019, and we wanted to compare the South Pacific as a benchmark for us, and compare it with the Red Sea basin of Egypt, as well as the Mediterranean basin. And we can see that there are some kind of events which are close by, or some kind of correlation with what's happening over the Pacific as well as other localities. And the reason for that, because we wanted to see what are the expectations for a location like Egypt or a location like Alexandria in terms of the water assessment, or the sea surface temperature, and what might be bringing in terms of massive amount of precipitation associated with the tropical-like events. So we started looking into a sea surface temperature anomaly or time series over that location, specifically looking into that, and applying different kind of signal processing techniques, starting with Fourier transformations, wavelet analysis, empirical mode decomposition, in order to see how the physical system is being driven. And we were able to observe some kind of peaks in specific years over Egypt and over Alexandria. We wanted this to be more localized, so the difference between Fourier transformation, it gives you the overall major cycle which is embedded in a data set, and you can see seasonality might be the major anomaly observed. However, wavelet analysis would be able to identify specifically on a time domain where are most of these observations. The year 2016 was kind of very interesting for us to see that massive jump in the precipitation anomaly that was observed on the Arab League region and also on Egypt. And this is the picture that I really wanted to share with you, which is a wavelet analysis done on massive time series, on a very long time series. And it was kind of interesting to see this very high signal with a lot of confidence, which appears on Egypt in the window of 16 plus years. You can see on the left hand side of the vertical axis, this is showing you the period in association with El Niño phenomena, and you can see there are some events that falls in the 4 years window, between the 4 to 8 years window, which is associated with El Niño, as we are aware. And then you can see some events in the 8 to the 16 years window, and you see a massive one in the 16 to the 30 or 20 something years window. And this is the expectations that we are looking into right now, that there might be an event of big precipitation event over the Mediterranean, closer to Alexandria waters, in the 20 years kind of window. which might be falling along the findings or what was mentioned by the Prime Minister from the UK in the Glasgow meeting. I know that my time has ended, so those other charts here were to show you the sensible heat fluxes in the motion. The idea that we are having here in Alexandria is to have an early warning system portal where it can look into high resolution forecasting modeling to be aware of what might be facing that city in the near future. And that concludes my presentation, and thank you so much for listening.
Thank you, Professor Elaskari. So we will proceed with the next presentation before the break. Unfortunately, Professor Dan Bloomberg couldn't join us, but he has sent a recorded video that I will share with you right now.
Hello to all of you. It is my honor to be talking to you today. I wish I were with you in the room at the moment, but unfortunately I'm on a flight and cannot attend the meeting in person. Next time, I promise you I will be there. In any case, I would like to talk about the use of remote sensing in challenges that are common to all our area, to the Eastern Mediterranean, North Africa, and the entire region that we all live in. Our region suffers from several problems that can be dealt with, or at least monitored, by the use of remote sensing. When we talk about our region, we must understand that much of our region is actually a desert area, suffers from lack of water, but at the same time requires a lot of food supply, and is one of the most prosperous areas for agriculture, and has been a prosperous area where people live in for many, many years. Here, I would like to show you a few photos of the entire globe. We can see the arid areas, this aridity map, which shows that the Middle East, North Africa in entirety is arid to hyper-arid part of it, and much of the areas that lie along the Mediterranean, even in Europe, are semi-arid. Some of them are not, unless you can see over here in Turkey, some areas are temperate, some areas of Italy are temperate, but most of the area is arid or hyper-arid. More than that, we actually share this kind of climate with many other parts of the world. Just looking at the map, we can see North America, we can see Australia, we can even see areas of South America that are arid to hyper-arid. And 1 billion people on this globe live in desert regions. Therefore, what we do in this area actually has an impact on the entire globe itself, on the entire world. The issues that we can look at, deal with, and actually try and understand using remote sensing include agriculture, something that's common to all of us, health issues like dust storms and how they impact health, water scarcity and water quality, water scarcity in North Africa, water quality in many of the lakes, alternative energy. For the most part, we're talking about solar energy, and even urban development. The urban centers in the arid areas of the Middle East, North Africa, and Southern Europe are growing and sprawling, and there are many issues that we can deal with using remote sensing. So studying arid lands using remote sensing is extremely important, and satellites provide two things, both the spatial data and the temporal data. In fact, if any of you go on to, for example, Google Earth at the moment, you can actually scroll back in time and see the changes that have occurred in our area. Obviously, we can do much more than that using full satellite images. So I actually encourage each and every one of you to go look at the Google Earth images now, but then use full satellite images, including multispectral, synthetic aperture radar, and thermal images to try and understand the changes that have occurred, and from that, conclude what might occur in the future in our region. If we look at this simple image of the country that I live in, of Israel, you can see the entire Middle East over here. You can see Israel over here in this area, and you can see that most of Israel is green due to the fact that we actually provide water. We have the Israel water carrier, which has now been reversed due to desalination, but we provide water to most of the country, including the Negev, the desert area in southern Israel. Most of the Middle East around us is still suffering drought. We have to work together to try and mitigate these issues of drought, the issues of dust storms, as you can see in this image in the center, and use satellite data to monitor the region without borders. So with this, I would like to thank you all, wish you a wonderful conference and a wonderful day. Thank you, and see you next time.
Many thanks to Professor Bloomberg for sharing this pre-recorded video with us. As we have a little shift in the schedule, we will now go to a coffee break, and we will continue in 11:40. So we will continue in 20 minutes. And we will continue. We continue with the next presentation. So the next presentation. Okay, sorry, we had some troubles with the voice. So now we will continue with the next presentation by Dr. Mohamed Fawzi Smij on space technology for socioeconomic development, activities and R&D projects in Morocco.
Okay, thank you. You hear me?
Yes, you can share your screen.
Okay. Show my presentation?
Yes. Can you put it on full screen, please?
Okay. Mm-hmm. Okay, it's okay? No?
Yes, yes.
Okay. Thank you. I am pleased to participate to this workshop to present some activities related to space technology and RID projects activity in Morocco. In our institution, remote sensing, Royal Remote Sensing of Moroccan Royal Center of Morocco. First, I will present very quickly our institution. The CRTS is a government institution which comes under the administration of the National Defense, and whose main mission is to promote the technology of Earth observation and the related technologies, to support ministerial departments, agencies, offices, and in their program and socio-economic development projects. The main mission is divided into 5 or 6 activities. The first consists in developing the use of space technology through sectorial and intersectorial projects and programs. The second is related to image access data, where the CRTS has built platforms and implemented procedures that facilitate and optimize access to image data to the users, or equally important activity are raising awareness and strengthening national and regional skills. The CRTS also participate in collaboration with Moroccan and foreign universities in research development projects and development projects in the field of space technologies. And finally, the CRTS represents Morocco in various international organizations and develops a partnership with international institutions. All projects and programs are built to support national sectors' strategy at national, regional, and local scales. For example, National Strategy for Sustainable Development, Water Strategy 2030, particularly for water saving, or Generation Green is for agriculture and irrigated areas. Value-added services based on Earth observation are developed in CRTS to support user community and respond to the need of users and decision makers in charge of socio-economic development projects at the national level. There is an active involvement of users in the development of application. Several ministerial departments and agencies are involved, Minister in charge of Fishery, National Agency of Aquaculture, Ministry of Land Management, Urban, and etc. The main goal of research and development activity is to develop or adapt solutions based on Earth observation to answer to the national needs. This activity is conducted in different manners. Research projects in collaboration with national and international universities, co-supervision of students, and offering training of trainers. Now, my presentation will focus on specific thematic application which concern some research activity. The first one is mapping in general, particularly urban mapping and land use. Many works was conducted by CRE to respond to urban agency and local authority specific needs related to benefit of accurate maps in urban and peri-urban area. These kind of works are produced by photo interpretation techniques, which are very tedious. Other example of this kind of application is mapping and monitoring of slums and non-regulated housing. This product concerns a very large superficie, more than 4,000 square kilometers and about 35 tons. To answer to the development of a new approach is necessary to produce map more quickly at different scales and with needed accuracy. The research activity in this context used deep learning approach, where learning database was produced in CRTS for many cities to detect building footprints. An example of deep learning model is ResNet. CRTS was developed a tool that can help users to test very many models of deep learnings to generate building footprints. Here's an example for result of footprints with deep learning footprints at scale at thousands and 5,000, 10,000 and 5,000 scales. In the land use mapping is the same, is very important for different kind of application. This application can the kind of information are frequently requested to estimate arrays of different crops and water consumption, respect for farmer rotation advocated by the board, agriculture statistics. This mapping are in this field, we are being implemented the same methodology to produce land use and land crops map for agricultural partners. Another field is drought monitoring and vulnerability mapping. As you know, due to its position in an arid and semi-arid zone, Morocco faced different challenges in relation to climate change, aridity, spatio-temporal scarcity, and irregularity of water resources, recurrent droughts. A system of drought monitoring was implemented in CRTS. The approach is based on a composite drought index, which is a graded composite indicator based on combination of 4 different parameters derived from satellite Earth observation products that are generated on monthly basis to produce CDI time series over Morocco at 5 km resolution. The CDI approach represents a remote sensing-based drought monitoring tool that incorporates information related to precipitation, evapotranspiration, land surface temperature as proxy to soil moisture, and vegetation index anomalies. A monthly bulletin is generated during growing season at national scale since 2003, where geographic entities are classified in 5 classes of droughts: exceptional, extreme, severe, moderate, and normal. Also, statistics are generated in different regions. Here you can this slide shows 4 growing seasons, the evolution of 4 growing seasons from the CDE between 2018 and 2022. Another study was conducted by my colleagues using the CDE is a structural drought vulnerability map. A methodology was developed to characterize structural drought vulnerability at national scale using composite drought indices, agrometeorology, pedology, land use, and also the poverty index. This map shows the geographical distribution of structural vulnerability to drought at qualitative and quantitative levels. Another domain is locust invasion risk. As you know, Morocco is directly menaced by this phenomenon that is related either to locust invasion from West African region, Mauritania, Mali, and Niger, or to locust reproduction in certain outbreak areas in the south of our country. Locust risk mapping was one activity of LDAS projects that was financed by the World Bank. After studying the environment condition for locust development, a model was built to produce predictive maps of locust presence. The methodology is based on the random forest model that was established by analyzing explanatory variable for locust presence absence, extracted from field surveys data, and satellite data representing the locust development environment, vegetation, soil moisture, and rainfall. This model produces desert locust presence probability maps for the next 14 days at spatial resolution of 25 kilometers. These maps are sent to the National Locust Control Center to help them plan future field surveys. The last example is the labeled Space Climate Observatory ERISAT Morocco project. Climate change has a great impact on water resources in Morocco. Saving water resource is an integral part of the new government water policy. Agriculture Department of Agriculture has developed a specific strategy for the irrigated agriculture to better manage and rationalize surface water use for irrigation, encourage more use of localized irrigation, rationalize the use of the groundwater resource. In this context, ERISAT project was conducted in this context. In this context, the labeled Space Climate Observatory ERISAT Morocco project wishes to valorize two research projects ERISAT Morocco initiated by the CERTES on the Tadla irrigate perimeters and energy balance approach, and SATIR is another project based on water balance approach initiated by CESBio in collaboration with the Qadi Iyad University of Marrakesh on the house irrigate perimeter. The two projects aims to provide local irrigation managers and farmers with a decision support system for water saving and productivity based on Earth observation techniques. This project aims to produce and disseminate indicators and advices on water consumption and productivity to farmers, to regional agricultural development offices, and the water basin agencies. Projects produce two kinds of products based on Landsat for frequency of 16 days and 30-meter resolution, and the tandem ProbaV vegetation for a vegetation indicator, and NPP VIRS for thermal band to produce daily products at 100 meters. The system consists of three modules. The first module uses energy balance CEBAL model to generate evapotranspiration, soil moisture, biomass, and nitrogen products daily or weekly at 100 meter or 13 meter. The second part generates irrigation indicators for plots, blocks, sectors, perimets, and basin. And the last one is the module that disseminates products to users. This table shows the indicator definition, their production frequency, and end user receiver. The indicator in light blue are related to water consumption and irrigation device. The green concern water productivity, and the yellow concern the temporal and spatial homogeneity of water availability in the crop zone, in the crop root zone. The project was, the initial ERISAT project was conducted in the Tadla irrigation perimeter located in the center of Morocco, near Atlas Mountain in the semi-arid zone. Here some figures that shows examples for products of these projects. The daily crops water consumption by plots, the water stress level by plot, and the based on threshold of the level of hydric stress. 3 types of irrigation advice are produced: no need, possible, and urgent irrigation. Also, soil moisture air is produced. So root zone soil moisture is also produced, and finally, estimated biomass daily production is also produced. For all the year, the total consumption is produced for each plot. A dissemination platform has been developed for different types of user, with each user profile having access to product at specific territorial subdivision from basin, sector blocks, sectors, blocks, and plots. Here, this is an example of consumed water in a plot. The farmer have the possibility to show variation in water consumption in determined time period. Another approach is a water balance approach, SATIR platform, conducted by CESBio et l'EMITREMA. This technology use remote sensing, meteorological data, and in-situ data to estimate plant water amount by water balance modeling. It produces also advice for farmer when and how much irrigated for the next 4 days. SATIR, this platform was tested on several experimental sites in France and in Morocco, in Moroccan house region. This slide shows the products for this approach. Each farmer subscriber benefits from a service where he can obtain information on the state of vegetation, on actual evapotranspiration, soil moisture, and the next date and quantity of irrigation of his plots. ERISAT Morocco now is opened to array of research improvement. The first one is improved spatio-temporal resolution of the energy balance approach by using high-resolution optical data, Sentinel-2, and low-resolution thermal data, VIRS, Moody's, S3, and Landsat, Sentinel-3 and Landsat. Also, establish a methodology to generate annual crop maps to enhance the accuracy of the model, and also use in situ estimation to validate the results of the model. Finally, create synergy between the two approaches, water and energy balance approaches, by using assimilation techniques. The partnership of this ERISAT Morocco is a consortium by CRTS, CESBio, and Office Régional de Mise en Valeur Agricole Durable, and research partner University Science Faculty of University of Mohammed V, Agriculture Institute Hassan II, and local partner other office and regional basin. And thank you for attention. These slides ends my presentation. Thank you.
Thank you for your presentation. So we will now proceed with the next presentation by Dr. Nikos Bartsotas on the development of precision farming services over formerly data-poor regions.
Thank you, Eleni. I'm just waiting in order to start sharing my screen.
I think now you can share your screen. Yeah.
All right. Is it okay now?
Yes, thank you.
All right. So, hello everyone. My name is Nikos Bartsotas. I'm a senior research associate in the National Observatory of Athens and the operational unit beyond Center of Earth Observational Research and Satellite Remote Sensing. Under the framework of Horizon 2020 project, namely eShape, we contributed through the development of novel services that mainly benefit the agro-insurance sector. But while Inter-American, that has initially been our main co-designer and end user, Inter-American is one of the largest private insurance companies in Greece. Initially shaped, the focus of our developments. Along the way, we have had farmers' cooperatives as well as farmers' associations and the industry presenting strong interest to our services. So I will briefly present what we initially developed based on what was expected and how it then evolved into something significantly broader along the way. As we live in an era that is characterized by wealth of data, we had an initial state of monitoring above our area of interest that was quite disappointing. We had a requirement from our end user, the insurance company, to focus upon Rhodope, which is a region in northern Greece, and cotton as a crop type. And while the region produces the second highest cotton yield nationally, the monitoring was sparse to non-existent, meaning one meteorological station in a city center was available, which obviously could not provide any insight. What did the insurance sector wish for? For instance, they needed to be able to differentiate the insurance costs and tailor them to each farmer accordingly. Also, in the case of a distraction, every claim, even now, has to be physically evaluated by an agronomist. And this is a procedure that is expectedly time-consuming and demands the farmer to leave a part of the crop intact until the evaluation will take place. And finally, there was no early warning directly related with the specific weather perils that affect the crop. So our plant architecture, that was an outcome of numerous meetings with our co-designers, was to invest in 4 main pillars. As a quick overview, we focused upon an adverse selection tool where the underlying risks associated with each parcel are identified in order to support the everyday work of an underwriter. A damage assessment tool, that offers a monitoring as well as an estimation of the areas that are clearly affected after a distraction. A high-level monitoring to assess the risk at which the insurance company is exposed to from a higher level. and an early warning, which is founded in a state-of-the-art numerical weather prediction model on a configuration that allows microphysical properties and especially convection to be resolved explicitly by the model dynamical core. So let's see each one of them in more detail. First and foremost, we created an adverse selection tool that would support the needs of the underwriter. After systematic literature review and consultation with agronomist experts, we identified the dominant factors that create distraction in the specific crop type, as well as the specific stage of the cropping season that each of those perils has the biggest impact. To build this tool, we would need long records in order to identify features with an impact in climatological terms. But given the absence of in situ observations, our analysis was based on reanalysis datasets from Copernicus Climate Data Store, specifically ECMWF's ERA5 land for 2-meter temperature and ERA5 for wind gusts, which are datasets that combine vast amounts of historical observations into global estimates using modeling and data assimilation systems. We also use the CIRPS, which is a validated precipitation product that blends satellite observations with in situ measurements from rain gauges. And in order to evaluate our hazard estimates and also have a sense of the vulnerability from each peril, we relied upon a 10-year record of damages in cotton crop over this region provided by the Greek Agricultural Insurance Organization, ELGA in Greece. Each of these aspects is both available in a dynamical map form as well as part of an info bubble that pops up on mouse hover above its parcel. The selection of parcels depicted here is indicative of cotton fields over Rhodope. And this service allows the underwriter to provide a tailored insurance rate to the company clientele judged upon the unique parcel characteristics instead of a uniform rate over a region, which is the current default. The second service that emerged in parallel to the adverse selection was developed by the EO team, of our group and our partner in Europublic in this research project. They worked upon a platform that monitors the current state of the parcels over a region through their private network of agrometeorological stations, as well as Sentinel-2 data retrievals, for which they utilize the NOAA Beyond API umbrella. The alerting mechanism ignites from the in situ observations. So if the value range of the observation is alarming, the following passes of Sentinel are analyzed in order to indicate if a sub-region is obviously affected. I have to mention here that in some cases, the NDVI values may drop significantly, but this is temporary. This only happens temporarily. So we have seen impressive rebounds and cotton crop can regain its health. So 2 or 3 passes are necessary in order to safely judge upon. The point here is to denote areas and parcels that are beyond doubt affected in order to promote rapid payouts. Also, there is a high-level monitoring option that assesses the risk that the insurance company is exposed to from a higher level, meaning what is the expected number of claims in the near future on a regional scale. This service currently displays 2 regions, Rhodope and Thessaly. In the former, there hasn't been any damage associated with cotton within the recent cropping seasons, whereas the latter was affected by a record heavy precipitation event that caused excessive flooding. And the service informs the insurance company how many of their insured parcels are expected to raise a claim. And last is the numerical weather prediction model that is the core of our early warning service. This one was designed from scratch in a newly acquired HPC node, where we implemented a state-of-the-art NWP model in a very fine configuration. It has been running operationally daily on a 2-domain setup. Europe has a grid spacing of 6 kilometers and Greece 2 kilometers, providing a full set of prognostic atmospheric and soil parameters. The visualization is in a most user-friendly manner with easy to understand thresholds from the end users that are crop specific. And as the resolution forecast the window is set to 2.5 days, we also included a 10-day outlook from GFS, which is a global forecasting system, in order to have a sense of the trends in the near future. So at this point, in terms of contractual obligations of the project, we would be fully compliant, but we made a strategic decision to broaden our user base besides the insurance sector and reach out to the source, which is the farmers themselves. We provided our service free of charge until the end of the project in exchange of data like parcels, yields, and field campaigns to evaluate our estimations. And we collaborate closely with two associations, a cooperative for cotton and another one on industrial tomato, both of which are very active and very highly engaged. So currently, on the precision agriculture services that we focus on this presentation, we ended up having three distinct sectors that need that we collaborate with on our services. Namely, it's the agro-insurance sector, it's the farmers' cooperatives, and it's also the industry, because we also reached out to the industry, and the paying collaboration has already blossomed with Corteva AgriScience. So in the agro-insurance sector, as already discussed, I want to focus more upon this. We have Inter-American as our main end user. Their operational needs sum up as follows. We have the underwriting that I also, elaborated upon, the damage assessment also, and the early warning. Another service that emerged along the way is that they had some cases where a client applied for insurance a few days before an extreme event. And given that people in insurance company are not meteorologists, they needed to be secure from similar practices. They couldn't know if a hailstorm was approaching. So we built a service where they just upload an Excel file with the list of the parcel coordinates under consideration. And this service produces a user-friendly color-coded matrix that denotes if it's safe to proceed with a specific contract or not. This is the agro-insurance sector. Next on the list were the farmers' cooperatives. We reached out to them and set up very fruitful collaborations. We focused on cotton crop and tomato crop because these crop types have critical seeding conditions. Cotton crop needs to have a specific ground or soil temperature in the first 10 centimeters, whereas tomato is already a plant during seeding, so it's critical not to have late spring frost episodes. Both are accommodated by our forecasting models in combination with artificial intelligence codes that daily denote subregions that are safe to seed, both in Thessaly and Boeotia. The feedback has been quite praising for the accuracy. This temperature measurement here, soil temperature measurement, was from a farmer that said, all right, you forecasted 17.2 degrees and it was 17.1. That's impressive. And I said, all right, I'm happy to hear that, but please don't expect, a 0.1 divergence all the time. So it's, very non-realistic. But in general, it has gone very, very nice. We steadily get very good feedback from the farmers' cooperatives. Irrigation and fertilization are also both weather-dependent activities. So on a parcel scale, we produce metograms for 2 and 10 days with clear threshold for each crop type specifically in order to make it easier to take necessary actions. The interesting part here is that the farmers of the stock cooperative for industrial tomato can access this information directly through their own cooperative service without the need to search for their parcel or anything. They just log into their cooperative service. They see their parcels, and by clicking a button, they get the forecast through the horizontal linkage that we have set up. And last is the phenological stage. In simpler words, the specific stage of the crop that the crop is currently at. That is essential for necessary actions, such as the application of growth regulators. Cotton, for instance, needs to be applied with a PIX regulator that stops growth when squaring stage is reached. And these plots here are from the same satellite retrieval, same date, for neighboring parcels. And based on our estimation, the parcel on top was at 40% leaf development, and the bottom one at 79%, which were fully confirmed from field measurements. Finally, users from the industry, such as Corteva AgriScience, that specializes in seeds and pesticides, or John Deere tractors or tomato factories, have different needs. They are after showing maps for more regions. We have recently set up a collaboration with Corteva to exclusively provide showing maps for cotton in numerous regions over Greece, as well as more crop types. And they are also after the conditions that demand the application of pesticide. We have focused upon a type of worm, green worm. We monitor its population in specific traps, then juxtapose them with our forecasts, and the first results are quite promising. The yield estimation, factories of industrial tomato, for instance, need to know what to expect and especially when to expect it. Given that most farmers deliver on a specific, let's say, wind time window within the cropping season, the factories of industrial tomato provide higher prices per ton when the production is delivered early on or late in the season. And we are able to estimate the expected production months before the harvest, judging upon the meteorological conditions that have preceded until that point, as well as the evolution of reference parcel during previous cropping seasons under similar conditions. And last but not least, John Deere tractors are equipped with sensors that map the production in an intra-parcel scale while harvesting. This is very important for us because with the 10-meter resolution of Sentinel, we are able to denote areas of delayed growth due to a number of reasons, like, for instance, irrigation faults. In this parcel depicted here, it was evident from the beginning that a part of it was falling back, and also later on in the cropping season, it continued to be behind, the rest of the parcel. So with ground data on intra-parcel scale, we can now evaluate all these aspects, and it's quite interesting. As an epilogue, it is rewarding for our effort that throughout just 2.5 years, we have gradually come to a polar opposite in terms of detail of provided information. We initially had one meteorological station to work with, and we ended up to this broad spectrum of the aforementioned tools and early warning systems that are tailored upon each specific user need. And it's also essential that we've received the user testimonies both from Inter-American as well as from the farmers' cooperatives that describe how useful it is to their everyday operational routines. So that's all. Thank you very much for your attention.
Thank you, Dr. Patsotas, for your presentation. We proceed now with the next presentation by Dr. Alexandra Chudnovsky on monitoring complex air pollution conditions using a wide range of remote sensing techniques in the Eastern Mediterranean region.
Do you hear me?
Yes.
Good afternoon. I mean, wishing you have an amazing and great day. And this is my great pleasure to present and to be here with you and to share results of our studies and how we can collaborate and how we can work together, how we can join our forces to make collaborations and joint research. So now I'm going to share my presentation. Just a moment. I would like to make sure that you see the presentation.
Yes.
Yeah, so monitoring complex air pollution conditions using a wide range of remote sensing techniques. So that's where we are. Tel Aviv University, we do have measurements, we collaborate. This is our location relative to, I wanted really to highlight how close we are to Cyprus University of Technology, and we can basically monitor a large long-range pollution transport event, and also to develop joint policy research on climate change. And also other speakers, as mentioned, in Morocco and Egypt, we all need to combine our forces. So let's have a look on Tel Aviv University. This is our campus and the facilities that we have to monitor pollution states. As I mentioned previously, we have PolyLiDAR. This is a joint collaboration with Tropos. And I know that also Cyprus University of Technology, you also very tightly collaborate. And my dear collaborators, I mainly work with Albert Ansmand, Ronnie Dietrich, and currently we do have joint publication. I also would like to share with you that Kevin also involved, and they spent a month in Israel last summer. So we built this site. I also presented it. It operates since 2019. Next to this site, we do have PM2.5, we do have IRONET, and we do have a couple of additional instruments that monitor basically chemical properties of pollution. We also learned from Cyprus University. On my last visit, I was very much impressed by your drone laboratory. So we also conducted field experiments. We cannot do more because we do have some issues in regulations, but we conduct field experiments where we installed temperature sensors, humidity sensors, and also PM2.5 sensors. And we mimic the real meteorological station. So our recent publications, really recent, 1-2 years, I didn't expand it more. So we study aerosol mixing conditions in the eastern Mediterranean. We combined numerous data sources. So this is not only LiDAR, IRONET, satellite imagery, and all available ground-based measurements. So we studied Haifa, very complex topographically pollution states, and how these pollution states bias satellite retrievals. So we also merged these data sets and combined for studied 3D measurements by using also multisensory assemblies of using drones. And we collaborate. We also use these our measurement facilities to highlight, to hint on water pollution. So we tried to investigate how atmospheric water quality can be, if we see tracers by using all this combined inventory. And I will provide you some examples. And just yesterday, our recent study was online published. Still requires proofs, but you can already see it online. We studied numerous complex air pollution conditions, in Tel Aviv area and how all these bias satellite retrieval. So let's have a look on these conditions. And currently we expand our study to classify all possible 3D layering pollution conditions in the Eastern Mediterranean region. And of course, we also conducted, I just wanted to bridge a gap on that air pollution and urban heat island. All these islands or hotspots in Tel Aviv or in any other Mediterranean region and any other region in the world that suffer from the increased temperature. And these islands might be correlating with air pollution. So where it is warm might be also heavy polluted. So this example, this hotspot, terrible hotspot, this is a highway, highly polluted, the most polluted area in Tel Aviv. And we also see that this area is suffer from increased air temperature. So we have only 4 meteorological monitoring sites. This is not enough to develop any policy. And our recent study, we collaborated with biological laboratory, and we put these very light sensors that we also put on drones or UAVs. And we succeed to cover the entire greater Tel Aviv area with light sensors and to provide some special interpolation, some spatial mapping on what's going on, what are the areas that are the most problematic and that's with increased or urban heat island area. And in these hotspots now we are going to put and conduct field experiments to study the air pollution dynamics. So let's have a look on our concept. So this is not only satellite data, this is not only LiDAR, this is not only drones. Where we can put these sensors, where we can put these instruments, we also use numerical simulations using different models, the best configuration, because the propellers impact the instrumental readings. And of course, we map. We measure this profile of the lowest profile below 200 meters, because we can also use this data as supportive when we analyze our LiDAR measurements, vertical profile with LiDAR. So we do have basically to the lowest layer to the up to 3, 5, up to 10 kilometers, depends on the pollution when we combine poly LiDAR measurements. But again, this the lowest profile, we do have some regulations when we want to run the field experimental work in the urban environment. Currently, we need to have we need to get permission from numerous authorities. Still, we succeed to conduct several experiments. We developed the concept of air pollution studies not only using our field experimental work, we also conducted enhanced literature, and we learned a lot from a Cyprus group, how to conduct the studies, how to conduct in our area, what is the best time, what is the best configuration of instrumental placements using drone setting that we employed in our experimental work. So just, you all know what is aerosol optical depth. Why I'm going to define it? Because satellite data, that is the basic retrieval. So it retrieves how polluted it is, some kind of estimates using radiance. All satellites measure radiance measurements. So, and then using radiance, they convert it to aerosol optical depth measurements. Briefly, how atmosphere is transparent. We get AOD, aerosol optical depth close to 0, is the atmosphere is transparent, close to 0. As the value increases, we do have more and more aerosols that interact with incoming solar radiation by absorbing and reflectance. So we do have more and more interaction, and basically this is a vertical integrated vertical properties. So I do not know where the pollution is if I use AOD from passive remote sensing measurements. So the integrated DZ, due to, as I mentioned, absorbance, the interaction with the aerosols. Of course, this is not mass properties, PM2.5. And all regulations refer to PM2.5 because that is what we breathe. And all the majority of health-related studies, they also relate to PM2.5. And both parameters that are not strictly correlated, because PM2.5 we measure at the ground, and aerosol optical depth is the integrated property. So we need vertical profiling, and that is exactly what we introduced. The LiDAR started operation in September 2019. Since then, we do have continuous measurements, and we share these measurements. Of course, we can share our data sources, and let's have a look how our satellite data corresponds to IRONET. IRONET measure exactly aerosol optical depth simply from the ground, so using sun photometer. And MAYAC is the algorithm, MODIS related, that provides aerosol optical depths at the special resolution of 1 kilometer grid size. So the correspondence when we have all data, R square 0.65, okay, not so bad. Let's have a look on the dot, red dot light, that all these black points within the relatively good correspondence, and we use LiDAR in order to investigate all these underestimation case. Then IRONET provides values that MAYAC satellite data is much lower values than IRONET, and also overestimation cases that MAYAC or satellite data provides much larger values when we compare to IRONET. So in all these cases, we detailedly analyzed LiDAR profile measurements. And as you can see, for overestimation case, of course, overestimation case is largely governed by clouds. But besides, when I reduce the impact of clouds, I can have the anthropogenic pollution. For the underestimation cases, for the overestimation cases, we can have two-layering condition with marine particles at the lower and natural and anthropogenic cases particles above. So 2 layers, 3 layers, not surprisingly, but it is always similar case, marine or breeze impact at the lower and the anthropogenic at the upper layer, or mixed pollution sources at the upper layer. So for the underestimation case is a mixed pollution in the lower layer. We can have dust, as you can have a look on the top. And we can also have the seasonal analysis, winter, spring, summer, and autumn. And we can see what season we do have the larger bias. So the larger bias, winter, summer, spring, autumn, roughly, we do have quite similar overestimation, but let's have a look on the underestimation. Spring, almost 50% in spring, when we do have dust transport events, we do have underestimation cases. This is quite a lot. And with all this climate change that we do have more and more dust storm events. So the satellite data would be largely underestimate our pollution cases. Of course, we can get support with numerous LiDAR parameters that can provide us or give us a better evaluation of pollution layering conditions when we do have underestimation and overestimation. We're using, for example, particle depolarization ratio, what we have using different thresholds for IronNet, using IronNet very low values, middle, and also large aerosol above 0.3. So here we can hint on maybe dust transport events. The first layer versus the second layer, how they differ and what leads to these differences. And we conducted classification of different layering conditions for all overestimation group and on underestimation case. So, so basically the next step of using all these groups, we analyze also not underestimation and overestimation. Our next step that we hope to finish this year is classification of all layering conditions also within this range. So we can have with some kind of typing what are the most typical layering conditions, how they changes over time, and how we can meet, maybe establish a policy like a kind of alarming system, and what we can expect, how we can these different layering conditions we can introduce also and implement in the climate change scenarios. I also promised to show you some kind of atmospheric water measurements we condensed, that is the collaboration with Dora Visar Lab, who measured water quality. So when we measure the atmospheric water, we basically find tracers of dust, not surprisingly, but also metals, I mean heavy metals from the anthropogenic pollution. And when we combine this for all those days that we find, these are LiDAR ratio box plots of 40-60 and 60-80 pollution. Pollution, which means 60-80 is anthropogenic pollution LiDAR ratio. So we see that dust already arrives to Eastern Mediterranean or Tel Aviv side. It is already highly polluted. And our facility, we very tightly collaborate with all LiDAR with Tropos Group. And our next stage is establishment of all big data sources, studying the land-sea breeze effects, boundary layer conditions, and all different urban pollutions and different mixing states. And another aspect, we also study anthropogenic pollution in the Dead Sea. So the Dead Sea areas highly suffer from it evaporates, and we do have very severe decreasing decreasing level of decreasing sea level, and we wanted to know if some aerosol transport on pollution patterns can impact how all both interrelates. So we do have, we can have a look at Israeli sides, Western and Jordanian side. So we have days that Israeli is more polluted, and we do have along the seashore, we do have a very, we do have industry we do have also Jordanian side, and we do have conditions on the D when both sides, eastern and western, are heavily polluted. So when we look at the long term and we analyze 20 years of data, this is the collaboration with Pinchas Albert, who also joined this research. We both guide our PhD student, Lisevel. And I apologize, I didn't mention my amazing student, that Irina Rogozovsky, and we jointly guide her with Albert Ansman. So regarding the Dead Sea study, when we analyzed synoptic conditions, that we see that this is the monthly average difference between different pollution levels, average difference between eastern and western side. So the positive value is west side more polluted, and the negative values is east side more polluted. Let's have a look on the time scale. So we have a look that in April, the dust storm season, east side with time become more and more polluted, and the result, as Pinchas ran numerous climate, he is a climatologist, expert in climate change. So he explained that we do have a change in synoptic systems. So we expect that severe changes in our area. And what next? As I mentioned, we continue to analyzing very in detail these varying aerosol conditions indicated by complex aerosol layering, complex aerosol mixtures, and we would like to take it in the concept of climate change events. This is very important input in global climate modeling, to include it in these complex aerosol mixtures, that we also can have a different estimates. And of course, this is a very important impact in all health environmental conditions, that we simply don't know what is the sources on every day. And these sources, pollution sources, are still not indicated in health-related studies. And we need to combine, study not only pollutions, we need to conduct it with air temperature. This is highly needed. And we need to combine not only air pollution, but also air temperature. They must be in symbiosis. And IPCC projection, let's have a look. I mean, this is now, okay, Eastern Mediterranean. We are integrated part of Middle East. Our pollution comes from Europe. We do have mixed pollution sources. And the problems that we have, they all suffer, and all presenters highlighted the droughts. We do have dust storms, even fires, flooding, the increased level water stress, weather extremes, and all these require joint forces. We need to develop the joint policy between all countries. We need to join our forces and work together. And to work together, if I look at temperature changes in the greater Tel Aviv, during the last 30 years, the temperature increased by at least 1 degree. So 1 degree increase in all urban areas. So I anticipate that the changes might be severe, and based on IPCC projection, it might be up to 2-3 degrees, which is really, this is huge for our area, and we need to see how we can mitigate these harmful effects. So my group and collaborators, so I work tightly with Rachel Lugas is my with my lovely work, she worked with my lab manager, my students, Blank, postdoc Lisever, Maya Sade, Irina Rogozovsky, master student Mali Nisnik, and Albert, Dietrich, Birgit, Holger, Roni, Alexei, Yuji, Alex Kostinsky. I collaborate with NASA, Pinchas, I mentioned, Zori Hini, with the big data. Currently, we analyzed all these data sources, how we can estimate. We develop very large models to estimate the temperature change using Google Earth Engine. And currently, I also work with Imperial College on all these extreme heat events in London. And I want to collaborate with Cyprus group, with all Mediterranean, Eastern Mediterranean, and to develop climate policy research on how we can mitigate all these harmful effects. I'm very much, thank you so much. I finished my presentation. Thank you. Thank you so much for giving me the opportunity to share our recent results and to express my wish to our joint collaboration. Thank you.
Thank you for your presentation. We proceed with the last presentation before the lunch break. That is by Dr. Charles Galtis on Malta's current research trends on the use of Earth observation data.
Can you hear me?
Yes.
Can you see my screen?
Yes. Could you put it on full screen?
I'll try.
Now we can see the presenters. Okay.
Okay. And this?
It's still the presenters view. You can change it from the display settings.
Uh-huh. Is it better?
No, but you can click on display settings on the upper. No, just put it on full screen and then.
Full screen and then.
Yes. And now go to display settings and swap presenters view.
Okay.
So now it's okay. You can start.
Very good. Very good. So I'd like to thank the organizers for inviting me again for this virtual workshop. It's always a pleasure to demonstrate what we're doing. And as the previous speaker has stressed, this is, I think, a very good opportunity for us to present our work, but also a good opportunity to find common areas of collaboration. So the way how I have presented today's presentation is, a generic exposition of what we do here in Malta with regards to the use of Earth observation data. But most important of all is to, provide a platform whereby all the presenters and participants of this workshop can identify areas that are common to us, and we can eventually collaborate in the near future. Elena, how much time do I have?
20 minutes.
Okay, good, thank you. So a very brief introduction on the University of Malta. I come from the University of Malta. It has a very long history, a 400-year history, and it's the leading higher education institution in Malta. And it has around 14 faculties, and plus a number of interdisciplinary institutes and centers, plus schools and the junior college, which eventually have the students coming in and choose their own subjects at university postgraduate level as well. And it conducts academic research and provides higher education settings in many areas, including sciences, of course. The University of Malta has an Institute of Earth Systems from where I come and where I work. The scope of the Institute of Earth Systems is to teach and provide research environment in on environmental issues and also rural sciences. So here we deal with agriculture, agrosystems modeling, apart from environmental management and planning. And our focus is on the Earth's complex and dynamic systems. It's not about pure sciences, but the application of all this knowledge towards a better, hopefully, a better environmental management. And that's what we seek ultimately in our graduates, is to go out there, take on jobs that in which they can use their skill sets that have obtained from our institute, namely to bridge all of what is important when it comes to environmental management. So apart from many other things, Earth observation becomes a very useful tool for them, a useful tool to introduce this at their own workplaces, but as part of the strategic objectives of the entities in which they are working. And of course, we all the time look for partnership and collaborative research and projects focusing on coastal management, biodiversity conservation, land use conservation, landscape ecology, environmental assessment and management, and so forth. One area of particular interest to us is air quality monitoring, and I really enjoyed the previous speaker and of course the studies that she was highlighting. So that was indeed of interest to us. So what I'm going to present here is more of a taster of what we are doing in this field, the field of the utilization of Earth observation data, and how we're tackling from a research point of view, but also from an application point of view. Also, with regards to Malta's needs when it comes to Earth observation data utilization. So I'll also be presenting, very briefly, areas where EO data is being used from a national point of view. And again, I will end up with a call for a collaboration, some food for thought, some areas where we can collaborate. And I look forward to your interventions if required. So this is me. I work at the Environmental Management and Planning Division of the Institute of Earth Systems. My research interests are meteorology and numerical weather prediction, climate change and impacts, Earth observation technology in many components, different components, atmosphere, marine and land, and geographic information system. This is also why I really enjoyed hearing the other speaker who was highlighting the importance of using numerical weather prediction for agrosystem modeling, and the other subcomponents, subderivatives of these very important indices that a good chunk of it is coming from Earth observation, especially when it comes to validation systems. So this brings me to one interesting study that we have just finished and we have just published as well on water and the PI journal. This is high resolution estimation of ocean dissolved inorganic carbon, total alkalinity and pH. This is based on deep learning, but what is most important here is the utilization of a good number of Earth observation platforms. As you can see in the mid part of this slide, we used Earth observation that provides through machine learning very, very important parameters or very important information that goes into this algorithm. Important information that relates to the state of the oceans, especially at the surface, but not only. So here we have, for example, atmospheric stability. So for this, we use the kinetic forcing, for example, winds, 10-meter winds, but also wind stress and similar products that are obtained from Earth observation to identify atmospheric stability. And as you all know, atmospheric stability, or the kinetic forcing of the oceans onto the ocean surface, is a very important dynamic that mixes the carbon dioxide that is found at the bottom or lowest part of the atmosphere with the ocean surface. And it's that initial contact point where we start seeing the dissolution of carbon dioxide and the generation of slightly acidic conditions. So if we go then to the thermohaline forcing, we can look at sea surface temperature, the same parameter that we heard about earlier during this workshop, sea surface temperature coming from various platforms. And for this, we used optimally interpolated data sets coming from Earth observation. Another very important data set here, we have sea surface salinity, again, a very important player here in the thermohaline forcing. So sea surface salinity is coming from from two satellite platforms, and they are not very good in sensing the ocean surface at a high resolution, but they are indeed fantastic sources to use from an Earth observation point of view as well. Again, another forcing that is very important in the carbon sequestration, and then therefore also in the carbon dioxide or carbonate availability, are these chlorophyll A concentration, surface reflectance and ratios, and these indices, PIC, POC, and the ratio of particulate inorganic and particulate organic carbon. These are very important indicators of the biological forcing, the biological dynamics that can take place on the ocean surface and within it as well. And from the water side convection and upwelling, we use depth of mixing layer and the bathymetry, something which is relatively fixed, bathymetry. But again, all of these four orange boxes here are very important initial conditions, let's say, that define the current state of the ocean. So out of this, we were able to model the salt and organic carbon, total alkalinity, and pH to produce the high resolution pH maps. As you can see, the top one, it's ANN artificial neural network estimated at 4 kilometers. And a comparison of it, this is over the North Atlantic region, a comparison of it coming from the Global Ocean Biochemistry Hindcast. And this is monthly, by the way. This is monthly rendition, but the top image that is produced by this ANN algorithm can be produced on a daily basis at 4 kilometer resolution. Very good source, we deem, for example, the monitoring of refugia that are very important for the maintenance of appropriate level of alkalinity in our oceans. And in doing so, we are preserving the marine ecosystems. As you all know, the ocean acidification parameter is very important for descriptor 7, for those who are familiar with the MSFD directive in the European Union region. So we need to maintain good environmental status, and therefore we need to maintain a constant hydrological conditions. And here it comes, the ocean acidification comes into effect here. We need to maintain a constant pH as much as possible without degrading our environment, our marine environment. Another very good use of Earth observation technology is to characterize the climatology of territorial seas. And here we can see By the way, Malta is very small. The territory is also small. So here we're seeing the 12 nautical mile radius of a total terrestrial territory of 316 kilometers squared. So it's a very small island or archipelago. And here we're seeing the use of monthly global precipitation measurements provided by NASA, which is an international satellite mission that provides precipitation values every 3 hours in millimeters per hour. And we have used this from a spatial point of view to characterize whether we have a heterogeneity in terms of precipitation, but also to look at magnitudes. To your left, we can see here yearly mean wind speeds at 10 meters above sea level. And we can see that this resource, which is a renewable resource, which is 10-meter winds, which can be extrapolated to higher levels, is in general terms over this temporal trend, we have a positive, significantly positive trend of mean wind speeds, magnitude in meters per second. So this is quite encouraging for renewable sources of energy, rather than to the harvesting of this renewable sources of energy. Another very important application of space activities that we're using is to characterize and monitor our urban environment. And when my previous colleague mentioned urban heat island effect, it was striking to our activities as well, because as you can see here, we have quite a good number of historical areas in the Maltese Islands. And when you have historical areas, you tend to find dense urban fabric. And where you tend to find dense urban fabric under a warmer climate, and that is the projection for the Maltese Islands to have a warmer climate, then we're bound to see a more stringent, or rather a more significant effect that leads to urban heat islands, especially to small areas within these historical clusters. So we are really looking forward to study the thermal stress for residents living in densely populated historical centers. And one way how to look at this is to look at how good the traditional roofs are that are found within these historical centers. As you all know, 400 years ago, we did not have concrete, but we had this technology that used permeable materials like limestone and lime-based layers. And they used to be applied on top of the roofs as a cool roof, knowing from an indigenous traditional knowledge, the conglomeration of this mix of permeable materials was able to lead to roofs that are able to cool the internal environment. Now, this fact has in recent times become less significant with the advent of technology, of concrete, but also of applying membranes that are impermeable to water. However, unfortunately, this has led to the change in the property of these permeable materials, in the sense that they stopped architects and the owners of these historical building, they stopped this functionality, this basic functionality of these traditional roofs. And what we're studying is this valorization of keeping the original function of these cool roofs, and therefore maintaining these or renovating these materials, these roofs, to allow this permeability to occur, this breathability to occur. And for this, we have used CompSat very high resolution data set in the red, green, blue, and in the near infrared, together with Sentinel 1 and 2. We utilize also drones to characterize this at a high resolution, because with CompSat data, it's still roughly some 2 meters in the red, green, blue, and near infrared. But with the drones, we can go down in terms of millimeters and centimeters if need be. And using also forward-looking infrared technology together with in situ sensors, we were able to characterize the properties of these traditional roofs. And now we're in the second phase, whereby we will be using all of this knowledge to characterize the thermal impact of these roofs versus modern roofs, still within a historical urban fabric, and to quantify the urban heat island effect as a result that will eventually be exposing residents in the area. So that is our objective in that respect. Another application that we're using with regards to Earth observation technology is to apply it for human healthcare. And we're using a select data set of EO coming from or identifying primary environmental and climatic factors to come up with a prototype health monitoring system. The idea is to have a system that uses AI as well to promptly detect a disease upsurge or outbreak in terms of hospital admissions and patient length of stay. So we're getting historical data, we're correlating that with environmental and climatic factors coming from Earth observation data, and we are then facilitating this kind of data analytics and then providing it to the national authorities and the managers of hospitals. So we have recently submitted an article with the title Digital Health Twin Applications in Healthcare. So the idea is to provide this capability, to make this capability available for national authorities. Other manuscripts are in the pipeline, such as the use of satellite image analysis tools for healthcare, and also air pollution methods and related weather parameters and remote sensing that are very, very good indices of for healthcare management. One interesting, perhaps interesting for some of the participants today is the use of Sentinel-5P data for air quality. You can see here the Sicilian Straits, the Straits of Sicily, how dense it is with transport, with cargoes, with shipping. And top left, you can see the vessel route density coming from AIS there. And you can see, therefore, the risk for worsening of the environmental conditions of both the oceans, but also of the atmosphere. And lower or bottom left image there shows the concentrations of NO2 that is detectable by the Sentinel-5P. So I'm referring to the streak there between the Sicily Island and the Maltese Islands there. And we can quantify that using Google Earth Engine. So figure 5 there is the time series of nitrogen dioxide average concentrations within the considered domain from the beginning of 2019 to 2020. So this was also a study that looked at the COVID impact, or rather at the closure or minimization of transportation during that period. We also can identify seasonality there with regards to the emissions from the shipping industry, shipping maritime industry. Figure 6 shows the time series of sulfur dioxide average concentrations within the domain from the beginning of 2019 till the end of 2020. This has resulted in a conference paper, IEEE 2022, to assess the air quality derived from marine traffic in the Central Mediterranean. Central Mediterranean is a hotspot area for shipping, and therefore we need to maintain a constant monitoring of the area with respect to air quality. Now, these are also some ongoing EO applications in Malta. For example, we're using Earth observation technology to look at bathymetry, shallow bathymetry. One interesting ongoing project is bee poll. This is in line with the conservation of bees, which, as you know, is very, very important for ecosystem dynamics, but also for food security. And in Malta, we're using medium to high resolution satellite images coupled with 2D neural networks to identify the best locations for translocating honeybees for crop pollination in Malta. There is a similar project ongoing in Croatia, and they are utilizing similar algorithms for this. And it's a very, very interesting, very important project that deals with conservation of ecosystems. And top down, you have also an indication there of downstream services of satellite-derived data for the Maltese islands, where data sets coming from Earth observations, but not only, are being collected under a common, let's say, infrastructure to make that available to the general public, which I think is a very important aspect of making available Earth observation data, but also the value-added products coming from them. We have recently participated in the ESA ESTEC event named New Capabilities and Countries in European Space Conference. This was organized by ESA, and I recall there were some participation also coming from Cyprus and Greece in this. So this was especially fruitful for countries that are will be participating under PECs. So this is the plan for European cooperating states in ESA, and Malta is one of them. And we highlighted these activities and these interests to a wider audience, and the interest was indeed very high. So we're looking forward to collaboration also with countries coming from Northern Europe. So to conclude, these are our current strategic objectives, and we look forward to collaboration on this. So, for example, we are really looking forward to develop innovative technologies for space-based imaging and remote sensing, not only for natural resources management, but also for cultural heritage, weather and climate. To improve the accuracy and resolution of satellite imagery. We're seeing a lot of super resolution now products coming from Sentinel-1, 2, and 3. So we're really interested in this. Why? Because we have a very small territorial area. So our dynamics occur at a very high resolution. So we need to really focus deep down at a high resolution or at all of these dynamics. To build ESA partnerships engaged in these fields, and to tap in more into artificial intelligence. And we heard quite a lot today about the use of artificial intelligence in a number of platforms. To collaborate with local communities. And also, we're looking for entities that are able to analyze big data. That's the challenge, as you all know. We have so much AO data coming in every day that it becomes a challenge to analyze all the data. Now we have cloud server computing, that's very good. And we have, JavaScripts available to be able to, without actually downloading that data, but we can access all the data on servers, on cloud servers. And that's indeed a big challenge, but also a big attraction to us because we can access, in doing so, a huge amount of data. Data visualization is becoming a very, very important aspect in the value added of all this information. As you all know, data visualizations aiming at communicating our findings to stakeholders is very important. So we're also looking for partners there. And of course, innovation. So with that, I thank you for your attention, and I do look forward for future collaboration. If you have any questions, please do ask. Thank you.
Thank you for your presentation. And I think we can see if there are any questions. So If there are any questions, you may also type in the Q&A. So if not, then we can proceed with the lunch break. Since we are a bit late with the schedule, we will be back in 1 hour, so 2:20 East European time. And we will proceed then with the afternoon sessions in 1 hour. So welcome back. We will proceed with the first presentation of the afternoon sessions. Actually, we will start with the second presentation until Professor Husa will join us. So we start with the presentation by Dr. Anis Çkirpene on water resources in Tunisia, main constraints and current research trends.
Thank you very much, Eleni. So I will share my screen. So can you see my screen now?
Yes.
Okay, so I will start. So thank you very much, Eleni, and many thanks for the ERATOSTHENES Center for inviting me for this 4th EXCELSIOR annual virtual workshop. I'm glad to make a presentation today about water resources in Tunisia, highlighting the main constraints and the current research trends. So to start, for people who do not know Tunisia, so Tunisia is a country belonging to the North Africa, Middle East and North Africa. It belongs to MENA region. So the total area of Tunisia is 164,000 square kilometer, with a population of 12 million and a half almost, with a growth rate of 0.83%. The population density is around 76 per square kilometer. Our official language in Tunisia is Arabic, and our climate is Mediterranean in the north, Saharan in the south. And for the other parameters, I will show them later in my presentation. So talking now about the Tunisia and water. So in Tunisia, we have a history with adaptation to the water resources. So many indices and historical manuscripts have demonstrated the sensitivity of the past civilization in Tunisia to water issue. For example, the Zagwan ruins, the Aghlabid basins in Kirwan, the irrigated system of Ibn Shabat in the oasis of south of Tunisia are the proof of resilience and adaptation of Tunisia to water resource, to water stress. So the water resources in Tunisia are rare, inequally distributed in time and space, and they are partially renewable. So going now to give you an overview about the national water balance. So this data is updated in 2020. So Tunisia is receiving 37 billion cubic meter per year as precipitation. So the green water, which is evaporated, let's say, evapotranspiration from plants, is almost 23.4 billion cubic meter per year. And the evaporation and non-recuperated runoff are 8.5 billion cubic meter. And what we can mobilize in Tunisia is just the blue water, which we can use in surface water or store in surface water or use from groundwater, is just 4.5 billion cubic meter, divided between surface water, which is 2.7, and the groundwater, which is 2.2. So if we divide this quantity of renewable water resources, which is 4.9, by the population, we will find the per capita volume. So Tunisia, for instance, is 467 cubic meter per capita per year. So we are under the water scarcity. So according to this index, we are under the water scarcity, which is 500 cubic meter per capita per year, and even under the water poverty, like many countries in the region, like Algeria, like Jordan, like Egypt, Morocco, and even some European country like Austria. So we are under the water poverty line. Actually, this the updated value for 2023 is almost around 395 cubic meter per capita during 2023. So talking now about the topography of Tunisia. So the country is dominated by coastal plains, which are here, low steppes and high continental steppes, with some mountains here. We call this region the dorsal, which control now mainly 7 watersheds. So in Tunisia, we subdivided the country according to this topography and to hydrological network to seven watersheds. And from the geological viewpoint, the country is predominated by sedimentary deposits. The ages are going from Permian to the Quaternary and recent. And we have a dominance of detrital and clay series from the Tertiary and the Quaternary in the plains, and carbonate formation on the relief. So almost all these plains are constituted by detrital and clay series to form what we call the alluvial plains. Talking now about the precipitation. So the precipitation is largely influenced by the relief in Tunisia. So we have in the extreme north of the country, northwest in the country, so precipitation can reach 1300 millimeter per year. And we have a gradient toward the south where we can just reach it when precipitation can be 0 or let's say less than 100 millimeter per year. And the average annual rainfall is 230 millimeter per year, which is equivalent to this 37 billion cubic meter per year, which fall in the country. So this distribution of precipitation controls the bioclimate of Tunisia. So we find in the extreme north subhumid, and we go gradually to the south to reach the Saharan bioclimate. If we go now to the surface water potential, so this is the spatial distribution of surface water. And this distribution is showing a big disparity between north and south. For instance, in the north, so the total is 2.7 billion cubic meter. 82% of this quantity is located in the north area of the country because of the abundance of the abundant precipitation. The south is just 12%, and the center, sorry, 12%, and the south is just 6%. So we have a disparity, irregularity in spatial distribution, and also in temporal distribution. So this is the inflow of surface water. And as you can see here, it's varying from values around 780 to reach maximum of 7,000. But if we go to the average, we find the 2.7 billion cubic meter. For that reason, now we say in Tunisia that our surface water potential is 2.7 billion cubic meter per year. The surface water quality also is an issue in Tunisia. 72% of the total surface water have a salinity less than 1.5 gram per liter. 22% their salinity is ranging between 1.5 grams and 3 grams, and 6% of this surface water they have salinity more than 3 grams per liter. So this how these 2.7 billion cubic meter are distributed in the country. So they are captured in 35 big dams, we call the big dams in Tunisia, which are mainly located in the northern part of the country, with a total capacity of almost 2.4 billion cubic meter. So this is the network of the big dams in Tunisia. We have constructed one ongoing construction and programming. And also in Tunisia, we have 234 exploited hill dams with a total capacity of 215 million cubic meter. And we have 909 hill lakes, smaller scale, with a total capacity of 95 million cubic meter. Sedimentation of these big dams is an issue in Tunisia. So, for instance, here we have the Malek reservoir, which is almost sedimented and is not used anymore for that reason. So, this is the Malek 2. This is the second. This is the dam. This dam is now under construction to replace the Malek. So to monitor these water resources, Tunisia have a monitoring network for the precipitation. For instance, we have 120 pluviographs with 70 data loggers, which are already installed in the stations. For the runoff, we have 75 gauging stations. So what I can add here that unfortunately, not all of them, few of them are equipped with data loggers. The others, we just have 2 measurements per year, one for the humid season and the other one for the dry season. And usually in Tunisia, during September and October, we receive big amounts of water, which cause flood. For that reason, we have a system of early warning of the floods, which is basically in the northwestern part of the country, composed of 130 stations and 11 call centers to manage these floods and mitigate their effect. Moving now to the groundwater potential. So the groundwater potential is also subject, so it's almost 2.2 billion cubic meter per year, what we can exploit from the aquifers. It's also showing some disparity from the north to the south. So if you go from the north to the south, the quantity so the shallow groundwater is decreasing, and the deep groundwater is increasing. So in the southern part of the country, we are relying mostly on the deep groundwater. However, in the other countries, we use the shallow aquifers. And in Tunisia, unfortunately, until now, we are just talking about difference of 50 meters. So less than 50 meters is considered administratively as shallow water, and more than 50 meters, it's recognized as deep water, deep groundwater or deep aquifer, which is not really reflecting the reality from the viewpoint of hydrology, as many hydrologists know. So the most of the shallow aquifers which are existing are overexploited, especially near the coastal area and in Kairouan region also, which is known for agricultural activity, intensive agricultural activities. So all these aquifers are overexploited. However, for the deep aquifers, we still have some the situation is lighter, and just we have some locations where the deep groundwater aquifers are overexploited. So if the groundwater is overexploited, how can we measure that? How can we appreciate that? So we can assess the situation by the measurement of piezometric levels, and this is, for instance, an example of groundwater table decline of this aquifer, which is good quality, deep groundwater with a good quality, used for drinking water supply. And you can see that the groundwater table is declining from 82 until 2020. So all the piezometers are showing this alarming situation. So most of these, let's say, red color aquifers are showing the same trend. So concerning the water quality of the groundwater, so 20% of the deep aquifers and 8% of shallow aquifers only have good quality. And in Tunisia, the good quality means that the salinity is less than 1.5 grams. So this salinity also is varying from the north to the south. So here, for instance, the groundwater, which is exceeding 33 grams per liter, is representing 50% of the total resources which are in the southern part. So in the southern part, we have abundant groundwater resources coming from the deep aquifers, but unfortunately, their salinity is usually more than 3 grams per liter, which cause also some constraints to their exploitation. The groundwater of Tunisia, of course, is monitored and controlled. And for instance, here, this is the map of the piezometric network, which covers all the aquifers all over the country. So with a total observation points, let's say, with 3,837 points, where we can measure the piezometric levels. And among these points also, there is a network for groundwater quality. And as I said, for the other monitoring systems, unfortunately, for these points, we just have 2 measurements per year, which is not sufficient. So in front of this situation of overexploitation, so Tunisia opted for the managed aquifer recharge, which is intentional injection of available surface water in the ground to be used later for exploitation. And this graph is mentioning the total volume which is dedicated for artificial recharge or managed aquifer recharge, which is really ranging from values of 14 million cubic meter to 66. So that is depending on the surplus, depending on the available water for managed aquifer recharge. So the MAR have some constraints in Tunisia, which the MAR is occasional, strictly depending on the available water resources. It is poorly monitored and practiced without scientific and technical optimization, which makes dealing with this managed aquifer recharge is really now becoming a challenge for scientists and for water resources managers. Now I'm going to talk about the non-conventional water resources, especially the treated wastewater. And according to the data delivered by the National Sanitation Utility of Tunisia, so the treated wastewater volume is increasing from 1997 here, 123 million cubic meter to reach almost 245 million cubic meter in 2016. But I know that the recent data is more than this value. And if we look to this volume, it could constitute one capacity of the big dams of Tunisia. So this is really very nice, very good resource, which should be exploited. However, only 23% of the wastewater treated plants are exploited for irrigation. And the irrigated perimeter with treated wastewater represent only 2% of the total irrigated perimeter area on the country. So we have a resource for non-conventional water. We have treated wastewater, but its exploitation is not really good. It's not sufficient. Tunisia also looked for seawater desalination, especially in the islands, in the two main islands, Kerkena and Jerba. So I know that Jerba is now functioning with 50 million cubic meter as daily capacity. This is now well known, and it's exploited by the national water company, drinking water supply in Tunisia. And two more projects in Sfax and Zarat also in these coastal regions are already also launched, and they contribute enormously in mitigating the increasing drinking water demand in the region. So in front of these water resources, we have many constraints which touch these water resources in Tunisia. And the first one is the water stress. So Tunisia, if we look to the level of water stress, which is the freshwater withdrawal as a portion of available freshwater resources, so Tunisia is exploiting 121% of its renewable freshwater, which is an alarming situation in a country with limited water resources. Also, in the same philosophy, so Tunisia is as same as the most MENA region countries. We are relying significantly on groundwater resources here. So groundwater resources is in red. So we are mainly using a lot of groundwater, and this can lead to overexploitation. And you know, when we have overexploitation, that means that we will have seawater intrusion, groundwater pollution, and we will finish with groundwater stress. The water quality is also an issue and the constraint, so additional challenges, because most of the hydro systems are subject of various contamination sources. So this is, for instance, Wadi El Bey, which is located in the northeastern part of the country, where the water, where many industrial discharges, industrial effluent are discharged inside this river, and this river is in connection, direct connection with the aquifer, and we have some data which I'm not showing here. We have some data which is really showing that the groundwater table, the groundwater, the aquifer are contaminated by these effluents. The second constraint is the climate change impact. So if we look to the results, let's say the provisions, so this is a reference period, and under the scenario of RCP 4.5, so there will be a reduction of the total water resources from 4 something until 2.6 under the RCP 4.5, and the situation will be much more severe under the RCP 8.5 until 2100. So the situation will be really severe if countermeasures are not taken in consideration or not done. Another constraint is the water use inefficiency. So the agriculture in Tunisia utilizes most of the available water, 78%. We have also low productivity. So, for example, in 2018, the contribution of the irrigated sector to agricultural production was about 35%. So it is very low. Another point that we have also noticed, the leakage from water distribution network. For drinking water, this leakage is 32%. And for the irrigation network, it reaches 40% due to the limited investment and the lack of maintenance. So we need a lot of money to invest in this infrastructure. Another constraint which is also very important, which is the data and information system. So we have a missing of an updated specialized agriculture and hydrological data infrastructure. So we have a national database of agriculture, which was launched in 2004. And unfortunately, it's not updated regularly to reflect the new data. So it needs to be updated. Also, we do not have the availability of long-term consistent records. So we have, as I told you, most of the measurements are just taken twice per year. So there is a need of continuous monitoring. We have also political and economic constraints. So the various national water strategy didn't take in consideration adequate consideration for the participation of all stakeholders. That makes that the water policy is highly centralized and water users are partially involved in agricultural water management. We have also the financial constraints which are increasing, and insufficient synergy between the different institutions also is observed, which makes the opportunity are overlooked. This is also an important constraint. To cope with this water resources constraint, let's say Tunisian specialists, they propose some transformation pathways, which are mainly acknowledging the role of water sector within climate actions. We should take in consideration the impact of climate change. We need some policy reform, so managing water demand while meeting essential social and environmental needs also is important. We need to take in consideration the virtual water concept, which was not taken in consideration in Tunisian water resources. Also, another point is managing cooperative water governance. So we should look to the governance also. And the last point, we should encourage innovation in the water sector. So many technological, institutional, market, and policy innovation has been generated, tested, and adapted, which can help adapting to the climate change and securing water supply. So this point is very important. Moving now to the main research themes. So currently, researchers in Tunisia are dealing mainly, let's say, with characterizing water availability and quality. Most of the research are dealing with just characterization using field investigations, spatial techniques, chemical and isotopic data, etc. Some studies also are interested in climate change impact on water resources. Few of them are using modeling. Another issue is water demand and consumption pattern, so using data analysis and governance models. And also few studies which are dealing with agricultural water management, the water governance and policy, integrated water resources management in general, and many fundamental research which are dealing with water treatment and nature-based solutions, which are unfortunately remaining at the lab scale, which are not used outside of the labs, or poorly used outside of the labs. And recently, we started also thinking about water, energy, food ecosystem needs, ecosystem nexus. So in my opinion, what we need, so we need to move beyond the characterization. We need to focus more on the exploitation of Earth observation data in hydrological research to support stakeholders in sustainable usage of water, like, for example, the specific platform providing spatial data of evapotranspiration and crop water needs, which Giovantos mentioned this morning. This is very important, and I discussed that with Stelios. So, and I find the idea is very nice, and which could be applied in Tunisia. Also, a second point is the use of advanced real-time monitoring system of hydrological parameters, hydrological data, soil moisture, groundwater table, surface runoff, so should be automatically recorded and shared via web or LoRa or satellite or any other mean. I think also that the multidisciplinary research activities are essential to cope with data scarcity. We should make some cross-disciplinary researches. And lastly, modeling and artificial intelligence applications are very important for early warning and decision support systems. Finally, some concluding remarks. So Tunisia surely is suffering from water scarcity. However, until now, it manages sufficiently its water resources. At least we provide the water even during the most severe period of shortage. Despite the various constraints, recent studies are still optimistic and believe that demand will be supplied even on the horizon 2030, but we are not sure after this date. So ameliorating the water management is tributary of some points like the use of reclaimed water in agriculture and industrial sectors. We should enhance the managed aquifer recharge as mitigation and adaptation. Desalination also of brackish water for drinking, not only seawater, but we should also move to the brackish groundwater of the southern part of the country. We should promote the use of agricultural species tolerant to salinity and hydraulic stress. And we should protect water bodies from pollution by legislation, by adequate legislation. And the final point is that more efforts are needed to valorize research results in the water resources management. And thank you for your attention.
Many thanks for your presentation. We will now proceed with the next one by Dr. Hariton Kalaitsidis on promoting collaboration on Earth observation with countries in MENA region.
Good afternoon. Thank you for the invitation. It's a pleasure to be here. I will deliver a short presentation on the ways that SIAM is working and how it is promoting collaboration on use observation with the countries in MENA region. I'll just start sharing my presentation. I hope you see it now.
Yes, thank you.
Good. So yes, I'm working at the Mediterranean Agronomic Institute of Pania. It's located in Crete, Greece, and we are actually part of an intergovernmental organization called the Center for Advanced Mediterranean Agronomic Studies. The mother organization has its headquarters in Paris. It was founded in 1962. And the main objective and the reason for founding this organization was to help the countries in the South Mediterranean and provide them with access to higher education, because those days the postgraduate education was not easily available, especially in those countries. And originally it started with the founding of two institutes, the one in Montpellier and one in Bari. Soon after that, the institute in Saragossa was founded, and the last one was the one in Chania, which was founded in 1985. The SIAM is actually an organization in which 13 member states are participating. And in many cases, it's through their equivalent ministries of agriculture. In certain cases, it's the ministries of foreign affairs are also involved. And we have a governing board, which is in which representatives from those member countries are attending every 6 months in order to provide guidance and hear what the SIAM is achieving, and provides them with a floor of what they would like SIAM to do for them. And through this instrument, have a collaboration between neighboring countries around the Mediterranean. So originally, the objectives of the institute, the organization, were primarily education, but through the years and the evolution of circumstances, these objectives are adapted and directed to address any needs that the member states have. So at the moment, we have an action plan which is based on around 4 pillars, and it's designed to be parallel with the SDGs of UN and trying to address those goals. So we are at an agronomic organization. Our primary goal is related to agricultural production. So food security and nutrition is one of the main pillars, because it's one of the most important goals that each country should achieve, try to achieve security. Inclusive development of the women and young people, as well as members of the society that are privileged. And one of the pillars, addressing crisis and resilience, whether it's a natural, as recently evolving climate change issue that is having an overall effect on all the activities, and in general protecting of the planet and management of resources in a sustainable way, and trying to reduce agricultural losses. So in order to achieve those objectives, the tools that we have is primarily the education capacity building. Each institute has a number of postgraduate programs, and many of the students who are attending those courses come from the African countries. And also we frequently organize short specialized courses. In addition to that, we participate in research projects and trying to promote research. In many cases, students that are attending the postgraduate programs are also involved in those research programs. Then, because of the international character that we have, and the fact that we have access to ministerial level to the administration of those countries, it's a ripe environment for promoting the networking and collaboration. In addition to that, we also collaborate with other international organizations like the Union for Mediterranean or the FAO. And in addition to the networking, we have open knowledge platforms where we deliver all the research collaboration activities we have. The cooperation activities include recently more than 150 cooperation projects with countries from North South Mediterranean. And as I mentioned, the political dialogue and the partnerships is facilitated through the participation of the 13 member countries in the governing. In terms of education, this is, as far as MAIH here in Chania is concerned, the 5 postgraduate programs we have is business marketing, on food quality and analytical industry, geoinformation in environmental management, which is the postgraduate program that I am responsible for, horticultural and biotechnology, and sustainable agriculture. As you can see from the graph, we have a strong participation of students from Algeria and Tunisia, as well as Greece and Egypt. And then we have, particularly this year, they have slightly fewer Lebanese students. Usually we have more than those, as well as Moroccan students. So the central South Mediterranean countries are very well represented as students here. And a lot of the students, when they complete the 2-year master program, very frequently continue to PhD education, whether here in Greece or in other European or countries outside EU, like Canada and the US. So we are striving to provide postgraduate education to those students coming from those areas. And then a lot of these students then become, as alumni, they become collaborators, and very frequently we have ex-students coming back to deliver courses, for example, or commonly participate in joint cooperation or research projects. I would like to give a short description of a few projects that are currently running or are recently completed. One is dealing with agroecology in North Africa. This is a Horizon Europe project funded by the European Commission. In this project, the main objective is to identify the optimum ecological practices for specific cases. We have identified 6 living labs in the areas. It's actually living labs that are under the establishment. Actually, the kickoff meeting for this network was last week. And the idea is to collect a lot of data from those areas, assess their particular circumstances, and identify what are the optimum best practices for their particular case. Earth observation comes into play in this project by delivering data on the land use and land cover, and characterization of the labs, both in terms of crop areas and agricultural fields, but also the natural environment and the urban areas that are usually near those crop fields. So this will give us the ability to expand and provide suggestions on best practices on the wider areas outside of living labs based on the statistical analysis. Another similar project was the one on Xylella fastidiosa. It's a bacterium that is causing significant problems, mainly in the olive industry, but also on other species like ornamental species or almond trees. The project had many objectives, had a lot of research trying to delay its expansion because it's present in like South Italy and the area of Alicante in Spain, also in Lebanon, but there is a high risk of contamination of other areas, trade of organic material. And the study, the task that we were involved in, had to do with the assessment of the vulnerability of areas around the Mediterranean, actually involving the entire Europe, but we also include North Africa in our studies. And we used satellite data to identify land cover and land use, because the type of crop fields is very strongly related with whether an area is vulnerable to the bacterium or not. And these results have been published. The project finished 2 years ago, and we had partners from North African countries, Tunisia, Algeria, and Morocco. So those were recipients of the products of this list. And finally, another project which is a bit older, it's been almost 10 years now, it's been completed, but it was funded by Hellenic Aid, following a memorandum of understanding between the Ministers of Foreign Affairs of Greece and Egypt, where we developed the educational material and held courses in order to train and educate personnel in demonstrations, but also scientific institutes in Egypt, the National Association of Remote Sensing Partners, as well as a laboratory on arid lands under the Ain Shams University. Also through this project, there were some equipment that were purchased and provided to the Egyptian partners in order to facilitate research and also monitoring of environmental conditions that help manage their resources better. That was part of a greater cooperation in countries. Finally, I would like to just mention a couple of publications that have come out of thesis from students that complete our course, Geospatial Management. Most recently, we had this year a student from Tunisia graduating. Work included predicting the land use and land cover in the prefecture of Anya, which is western part where my resides, using the Markov and cellular automata model, originally using data from Korean, and generating predictions on how the land covers will change in the near future. Another example is a study that we did about mapping agricultural lands and trying to identify abandoned agricultural land as a potential threat of fire risk in the area, mainly the south of the Peloponnese and the island of Crete. And we used the time series data in order to map the agricultural land and monitor how the land cover and land use changes through years from the mid-80s to 2020. And we have noticed some trends where a lot of the arable agriculture and permanent agriculture have been permanent in relation to each other, but growing overall, especially in the recent years. But there have been some fluctuations in the rate of agricultural gain for permanent agriculture over years. This was done in collaboration with the Idaho University in the US, and one of our students in Tunisia as well did her thesis on this project. The project was funded, I think, from NASA in the US. And finally, had a collaboration with University in Saudi Arabia, where a student from Egypt had a study on using satellite imagery, but specifically Landsat, in order to monitor the variability of crop cover and in relation to the amount of biomass harvested for alfalfa. And that was years ago as well. And another example of how our institute intervenes in order to supply education to students coming from those countries. So, and to close, here's a quick look of the major collaborations we have around the EMMENA region. We have a lot of students and also participating in some projects with the University of Morocco, also with the University of Tizi Ouzou in Algeria. We have some projects with INGREF and actually collaboration right now with them. As I mentioned, with the project of Egypt, the Ain Shams University and NARS partners we have collaborated in the past. With the University of Balamand, but also the Lebanese University, we have a lot of students coming from those areas. But the University of Balamand, we have an ex-alumni who's now professor there and is delivering courses to the program. The two institutes, one, the King Saud University, was through the study I mentioned before, but also another alumni student of ours, University in Jeddah. And finally, we have a new collaboration with the Lebanese International University. It's a new university, but it's spreading to various areas. They have a campus in Yemen, and they're now, I think, trying to set up something in Ethiopia as well. And we're in close contact with them in terms of educational collaboration. So thank you for your attention, and I'm available if you have any questions and open to future collaboration.
Thank you for your presentation. I think we can proceed with the last presentation, and if there are any questions, we can address them after the last presentation. So the last presentation is by Ms. Liana Stavru on addressing the impact of climate change on infrastructure using space technology.
Hello, everyone. Can you hear me well?
Yes.
Okay, I'm going to share my screen. Okay, can you see my presentation? Okay,
Yes.
First of all, thank you for arranging this workshop and thank you for inviting us. It's a pleasure for us. I'm Stiliana Stavru. I'm a remote sensing geologist at Geofem, and today we'll address the impact of climate change on infrastructure using space technology. A few words about Geofem. Geofem was established in 2007, and it combines the three disciplines: geotechnical engineering, satellite remote sensing, and GIS, to help maximizing the resilience of its infrastructure and then build environmental behavior to use climate change and geohazards. And this is an overview of the content. We'll see how crucial it is to monitor the infrastructure, the Great Infrastructure Challenge, case studies of monitoring infrastructure and the effects of climate change, and the artificial intelligence usage of AI for infrastructure susceptibility to geohazards. First of all, we need to know why it is crucial to use the space technology and specifically the remote sensing for assessing and monitoring the infrastructure. Firstly, constant monitoring is essential work to determine if the city and its infrastructure are well preserved. Secondly, due to the increased population nowadays, we have many vehicles and overloaded bridges and roads. Due to the climate change, we have many severe damages to infrastructure, agricultural land. So we need to control and be aware of what climate change could do to the land and infrastructure. And lastly, the people need to know and familiarize themselves with the cost-effective monitoring methods for assessing the problems with the catastrophic events. Some geohazards are the coastal erosion, landslides, sinkholes, and clay subsidence, which do not cost only money for life, they cost also human beings. Geohazards are very difficult to manage, and yet the numbers continue to increase with climate change. Well, now we'll see how, with the use of space technology, we can monitor different types of geohazards. Cheaper, it's a cheap method. It could be a cheap method because we can use open source data. It can be a fast method because we can, after the first processing, we can have the results after a few days. It is really accurate method with millimetric accuracy and high frequency. It is a non-disruptive method. It is automated, and we can go back in time. Retrospective means that we can use old data to do a historical analysis. SAR stands for synthetic aperture radar. SAR satellites emit electromagnetic waves to the Earth's surface, and they measure the reflected waves back to the satellite. And this is how we measure the displacement. It's unaffected by the cloud coverage, and it can operate day and night. This is the SAR wave. This is how we measure the phase, which is the displacement measurement. It's the phase difference from the object to the satellite. It can be done by over 2 passes of successful passes over the same location, and the amplitude measurement is the soil moisture measurement. As you can see here, the phase difference, displacement measurement, and the amplitude. We can have 2 tracks, the ascending and then descending image. So we can have 2 points of views on an area. And now we can see some applications where we use the INSAR monitoring. First of all, landslides, which can be triggered mainly by rainfall, heavy rainfalls, and of course, climate change can impact the occurrence of landslides. This is a landslide in Missouri in Cyprus, which after a very heavy rainfall in 2001, you can see the direction of it. You can see that the road is destroyed here, and it caused the loss of the damage of 3 residences. Here is our web GIS platform, IGIS, where we illustrate present the results. You can see that we can see the 3D version of the base map, and here is the landslide in Missouri. You can see the displacements. The red color means that we have big high values of displacement, and the green dots scattered points means that we have stable, generally stability there. We can plot the point here. You can see the latitude and the longitude, also the line of sight velocity, also in tabular formatting. We can download the table and the chart. Also, we can combine the points and see and compare them, compare the displacements. And here is a screenshot of the selected points. Another big landslide in Limnes, again in Cyprus, in Missouri village. Here is a raster layer where we can see in the center of the map that we have increased displacement. It's a horizontal displacement. It means that we merge ascending and descending images to create a decomposition. After the decomposition means that we can have the horizontal and the vertical displacement. We can see here that the positive values have the blue color, which are bigger than 190 millimeters, and the red color, less than -19 millimeters. Here again, with a different, we run the same location with a different monitoring period. And again, we have the same increase here in the center of the raster in the map. Again, here we have more than 200 millimeters. Before we have a bit lower number. Another landslide is a Pianello landslide in Italy, in Bovino province. Here is the area that we wanted to run the analysis and check the area. And here are the results. We can see here these positive values around 70 millimeters over the 2-year study period from February 2020 to January 2022. Horizontal displacements of maximum 60 and more than 60 over the 2-year period study. And here is a combination with the FEA modeling, finite element analysis. We can see here the model that the engineers created, stability and the prediction of the failure. Another application is the monitoring of dams, tailings dams and dams. Oh. Okay, this is a dam in Cyprus. Again, it's crucial to monitor dams. It is expected to have some displacements, but we need to monitor them and make sure that they do not exceed some threshold, because they could be very dangerous. Here you can see in the center that we have displacements. It doesn't mean that necessarily they are really big. That's why we need to monitor them. And some stable points. Another application is the swelling clays. Swelling clays are materials in the soils which can expand and shrink, which means that they can change their volume, which is a really bad consequence in the infrastructure, as they can create cracks and subsidence or partial subsidence. You can see here this graph after the wet season has increased values, which means uplift, and after the summertime near November, right after the summer, November, October, it shows lower values. This seasonality can be detected from the INSAR applications. And here you can see a railway in Northern Ireland, which shows increased displacements on the tracks of the railway. Always, most of the times, railways are good scatters, so that's why we get so many points on the tracks. Here you can see it. This is a zoomed image where you can see the increased displacements around 30 millimeters, 25 to 30 millimeters over the 2-year period. It's crucial to monitor the railways because we use them daily, not here in Cyprus, but yes, infrastructure susceptibility to geohazards. By using satellite data and displacement data, soil moisture data, and topographical data, in combination with other data which are geological maps, asset damage data, ground truth data within in situ measurements, through the artificial intelligence and engineering know-how, we can create susceptibility maps for landslides, swelling plains, sinkholes. And here we can see a video about this susceptibility map. Here you can see the classes: no susceptibility, low susceptibility, yellow color, orange color, moderate, and high, the red color, which this map can indicate the susceptibility to avoid building on an area and to be aware of what is going on this area. Thank you very much.
Thanks for your presentation. So that was the concluding presentation for today's workshop. I think we can wait for some time if there are any questions. So you may use the Q&A for any questions. There was already one question that was answered. So the question was for Dr. Anis Çekirpene. Thanks for the really nice presentation. The question was about drought monitoring in Tunisia. and if there are any studies that integrate remote sensing and in situ data for that purpose, and if not, if you think that this is something that could be of interest for the Tunisian authorities. And the reply from Dr. Çekirdağ says that few studies have focused on drought monitoring using remote sensing. And indeed, more efficient methodology could be interesting for the authorities. So I think there are no other questions. On behalf of ERATOSTHENES Centre of Excellence, I would like to thank everyone for their participation. And thanks also to our speakers for the insights in trends in the EMMENA region. We see some common trends and some common challenges that we need to face. And through future synergies, hopefully we will achieve more in research and innovation in the EMMENA region. Have a nice day to everyone and hope to see you in our next online talks.